You have lived your entire life with a feeling of certainty. You are sitting somewhere right now, perhaps on a soft chair or a firm mattress. You can feel the weight of your body pressing down, the solid resistance of the ground beneath your feet, the smooth glass of the screen you're looking at. If you reach out and tap the wall, your knuckles meet a hard barrier. It makes a sound. It stops your hand. Your senses tell you a story that is simple, comforting, and absolute. The world is made of solid things, and you are a solid thing living within it. This solidity is the foundation of your sanity. It is the unspoken contract you have with reality, that the floor will hold you, that the walls will shelter you, and that the air you breathe is distinct from the body that breathes it. But this contract is a lie. The solidity you feel is an illusion so convincing, so total, that it has fooled every human being who has ever lived until very recently. The truth, the terrifying, beautiful, and silent truth, is that there is nothing there. If you were to look at the world as it truly is, stripping away the convenient hallucinations of your biological senses, you would not see chairs, or walls, or skin. You would see a vast, silent emptiness, punctuated by tiny, lonely specks of matter so small that they are almost effectively non-existent. You are a ghost inhabiting a universe of ghosts, floating in a void that pretends to be a room. To understand why this is not just a poetic metaphor, but a literal, physical fact that keeps physicists awake at night, we must descend. We must shrink down, past the level of the dust mites that crawl on your eyelashes, past the bacteria that swim in your gut, past the twisted ladders of DNA that coil in your cells. We must go down to the atomic level, the fundamental pixelation of our reality. Imagine for a moment that we can expand a single atom of your body until it is the size of a great cathedral, a vast dome of silence stretching hundreds of feet into the air. You might expect that this cathedral is filled with stuff, with the building blocks of matter. But as you walk into this atomic cathedral, you find nothing. It is empty. The air is still. There are no pews, no altars, no stone columns. You look for the nucleus, the heavy heart of the atom where almost all its mass resides. In this cathedral-sized atom, the nucleus is not a large altar in the center. It is a single housefly buzzing in the exact center of the vast open space. That tiny speck, suspended in the dark, is the only solid part of the structure, and the electrons, the particles that define the boundary of the atom, the things that give it size. They are not walls. They are not even gnats buzzing near the ceiling. In our cathedral analogy, the electrons are invisible clouds of probability, ghost-like shimmers appearing and disappearing miles away from that central fly. Everything in between, the vast echoing space between the tiny nucleus and the distant, ghostly electrons, is void. It is emptiness, pure, unadulterated nothingness. If you were to take a human body and remove all this empty space, if you could somehow squeeze the nuclei of your atoms together, eliminating the vast voids between them, the entire human race, all 8 billion of us, would fit inside the volume of a single sugar cube. Everything else, the entirety of the volume you think you occupy, is just a hollow shell. You are 99.9999999% empty space. So, here is the question that should make your skin crawl. If you still believe in your skin, if you are mostly empty space, and the chair you are sitting on is mostly empty space, why don't you fall right through it? Why doesn't the ghost of your body simply pass through the ghost of the chair, like smoke passing through a screen. When you touch the arm of your chair, you are not actually touching it. This is one of the most unsettling realizations in all of physics. Touch is a fabrication of your brain. What is actually happening is that the electrons in the atoms of your hand are approaching the electrons in the atoms of the chair. Both sets of electrons carry a negative electrical charge. And as you know from playing with magnets as a child, like charges repel. As your hand gets closer to the chair, the electromagnetic force, a force billions of times stronger than gravity, pushes back. The electrons in your skin are repelled by the electrons in the fabric. They never touch. They never even get close in atomic terms. There is always a tiny microscopic chasm between them, a gap that can never be bridged. You are hovering. You are always hovering. When you hug someone you love, you are not really touching them. You are feeling the electromagnetic resistance of their atoms repelling yours. The sensation of pressure you feel is just your nerve endings reacting to this repulsive force. The warmth you feel is just the transfer of kinetic energy across that gap. Air molecules dancing between you. You have never touched anything in your life. You have never touched the ground. You have never touched your food. You have never even touched your own face. You are floating in a force field, forever separated from the rest of the universe by a barrier of microscopic rejection. This realization changes the way you look at a wall. It is not a solid barrier. It is a field of force. It is a swarm of particles vibrating in the dark, creating the illusion of a surface. And this illusion is fragile. For thousands of years, we believed matter was solid because it looked solid. The ancient Greeks debated what matter was made of, but they assumed that at the bottom of it all there was something hard, something durable. They called it atomos, the uncuttable. They imagined little billiard balls, hard and unbreakable, stacking together to build the world. This comforting picture was destroyed in a dark laboratory in Manchester, England, in the year 1911. A physicist named Ernest Rutherford was trying to see inside the atom. He didn't have a microscope powerful enough. No one did, and no one ever will, because atoms are smaller than the wavelength of light itself. So he used a different method. He fired tiny, positively charged particles, alpha particles, at a sheet of gold foil. The foil was incredibly thin, only a few atoms thick. Rutherford expected the alpha particles to punch right through the gold atoms like bullets through a cloud. If atoms were soft, pudding-like balls of positive charge, as was thought at the time, the fast-moving particles should have sailed through with barely a nudge. Most of them did. They flew through the gold foil as if it wasn't even there, hitting the detector screen on the other side. This confirmed that the atom was mostly empty. But then, something impossible happened. Every once in a while, perhaps one in every 8,000 shots, an alpha particle would hit the gold foil and bounce backward. It would ricochet off something hard and heavy inside the void, flying back toward the source. Rutherford was flabbergasted. He later said it was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. That tissue paper was the gold foil. The shell that bounced back told Rutherford that deep inside the empty cloud of the atom there was a tiny, incredibly dense point, the nucleus. The discovery was hailed as a triumph of science, but it opened a door to a new kind of existential dread. It meant that solidity was a trick of perspective. It meant that the only reason we can't walk through walls is not because there is stuff in the way, but because invisible forces are pushing us back. But the terror goes deeper than just empty space. The classical model of the atom, the one you likely learned in school with little planetary electrons orbiting a sun-like nucleus, is also a lie. It is a comforting diagram we draw for children because the truth is too difficult to draw and perhaps too difficult to accept. If an electron were a tiny planet orbiting a nucleus, it would eventually lose energy. It would spiral inward, crashing into the nucleus in a fraction of a second. If atoms worked the way we think planets work, every atom in the universe would collapse instantly. You, the chair, the earth, the stars, everything would implode into a puff of radiation. The fact that you exist, that you are stable, that you are reading this right now, is a miracle that classical physics cannot explain. Something else is keeping the atom inflated. Something else is preventing the collapse. We are standing at the precipice of the quantum realm now. We have stripped away the solidity of the chair and found it to be a force field. We have looked inside the force field and found it to be 99% empty space. We have looked at the tiny specks of matter inside that space and realized they are not following the rules of motion that govern our world. The terror isn't that the world is empty. The terror is that the stuff inside the emptiness isn't really stuff at all. When you look at your hand, you are seeing a stable pattern of light and shadow. But the carbon atoms in your skin, the iron atoms in your blood, the calcium atoms in your bones, they are ancient. They were forged in the hearts of dying stars billions of years ago. They have been part of asteroids, part of dinosaurs, part of ferns and oceans. Now, for a brief cosmic moment, they are you. But what are they? If we try to pin down that electron, that tiny fly in the cathedral, we find that it refuses to be pinned. It is not a ball. It is not a point. It is a smear of probability. It is a ghost that can be in multiple places at once, or nowhere at all, until it is observed. This is where the sleepy scientist in you must wake up to a new kind of dream. A dream where reality is not a fixed stage, but a shimmering ocean of possibilities. You are not a solid object moving through a solid world. You are a probability cloud interacting with other probability clouds, suspended in a universe that is more thought than thing. The silence of the room around you is heavy with this knowledge. The air molecules bouncing off your skin are not tiny marbles. They are wave functions collapsing and expanding in a rhythm too fast for you to perceive. You are effectively blind to the true nature of reality. Your eyes evolved to see tigers in the grass and fruit in the trees, not the quantum foam that boils beneath the surface of space-time. We are shielded from the terror by our size. We are giants lumbering through a world of averages. We don't see the individual chaotic dance of the atoms. We only see the statistical stability of the crowd. But just because we cannot see the chaos doesn't mean it isn't there, seething just beneath the surface of your fingertips. In the next chapter, we will dissolve the illusion even further. We will look at what happens when we try to look at these particles and why the simple act of watching the universe might be the only thing that forces it to make up its mind. But for now, sit with this thought. You are a cathedral of silence. You are a vast empty space held together by invisible forces, floating in a dark universe, touching nothing, alone in the void. And yet, somehow, you feel solid. That feeling is the greatest magic trick in the universe. And we have only just peeked behind the first curtain. Have you ever wondered if the world disappears when you close your eyes? It is a question that children ask, usually while lying in bed, staring at the shadows dancing on the ceiling. They ask it with a playful giggle, testing the boundaries of object permanence. You, as a rational adult, likely smile and assure them that the world is very much still there. You tell them that the toys on the floor, the moon outside the window, and the tree in the yard continue to exist in exactly the same state, whether they are being watched or not. You tell them that reality is objective, that it does not care about the observer. You tell them this because it feels true. It feels safe. It is the bedrock of our classical understanding of the universe. Things are what they are, regardless of who is looking at them. But once again, the universe has a secret, and this secret suggests that the child's question is not playful nonsense, but perhaps the most profound inquiry a human being can make. In the previous chapter, we dissolved the solidity of your chair and your body, revealing that you are a cathedral of empty space held together by force fields. Now, we must go deeper. We must step into a dark room, a laboratory of the mind, to witness an experiment that has haunted physicists for over 100 years. It is called the double-slit experiment, a name that sounds dry and technical, but which hides a mystery so unnerving that it dismantles our concept of reality itself. Imagine a calm, quiet pool of water. The surface is like a dark mirror, perfectly still. Now, imagine a barrier placed in the middle of this pool, a solid wall stretching from one side to the other. In this wall, we cut two narrow vertical slits side by side. We will call them slit A and slit B. Now, on one side of the wall, we begin to create waves. Perhaps we tap the water gently, sending ripples spreading out across the dark surface. When a wave hits the wall, most of it bounces back, but some of the water passes through the slits. A small semicircle of ripples emerges from slit A, and another set of ripples emerges from slit B. As these two new waves spread out on the other side of the wall, they eventually run into each other, and this is where the magic of waves happens. Where the peak of one wave meets the peak of another, they combine to make a double-sized peak. Where a trough meets a trough, they make a deeper trough. But where a peak meets a trough, where the high water meets the low water, they cancel each other out. They flatten into nothingness. The water becomes still. If we placed a screen at the far end of the pool to record where the water was moving most violently, we would not see just two bands of activity corresponding to the two slits. We would see a complex pattern of many alternating bands, bright stripes of intense motion separated by dark stripes of stillness. Physicists call this an interference pattern. It is the fingerprint of a wave. It is the signature of fluidity, of something that can be in many places at once, spreading out and interacting with itself. Now, let us drain the water. Let us dry the pool. We are going to change the experiment. Instead of waves, we are going to use particles, matter, solid things. Let's use marbles. Imagine we have a machine that fires marbles, one by one, at the barrier with the two slits. You fire a marble. It flies through the air. Maybe it hits the wall and bounces off. Maybe it passes through slit A. Maybe it passes through slit B. It travels in a straight line, hits the back screen, and leaves a mark. You fire another and another. You fire thousands of marbles. At the end of the experiment, you look at the back screen. What do you see? It is simple logic. You see two vertical bands of marks, one band directly behind slit A and one band directly behind slit B. The marbles that went through the left hole hit the left side. The marbles that went through the right hole hit the right side. They are solid objects. They take a path. They arrive at a destination. There is no interference. There are no mysterious extra stripes. This is how the world works. This is how you expect reality to behave. But now, we descend back into the quantum realm. We replace the marbles with electrons. Remember, electrons are the tiny specks of matter that orbit the nucleus of an atom. They are the building blocks of the physical world. They are what you are made of. So, we set up our electron gun, a device that fires single electrons, one at a time, and we aim it at a barrier with two tiny slits. Behind the barrier is a sensitive detector screen that lights up whenever an electron hits it. We start the experiment. Click. An electron is fired. A tiny dot of light appears on the back screen. Click. Another electron. Another dot. It seems comforting. It looks like the marbles. We are firing tiny bullets of matter, and they are hitting the wall. We leave the machine running for an hour, firing thousands of electrons one by one into the darkness. We go for a walk. We drink a cup of coffee. We relish the certainty of a solid universe. When we return, we look at the pattern on the back screen, expecting to see two bands of light, just like the marbles. But we do not see two bands. We see an interference pattern. We see a series of alternating bright and dark stripes stretching across the screen. We see the fingerprint of a wave. Let the silence of this moment sink in. We fired particles. We fired tiny rocks of matter, and yet they behaved like water. But it gets stranger, much stranger. If we were firing a stream of water, the water molecules would all be pushing against each other, creating the wave. But we fired the electrons one at a time. We waited for the first electron to hit the screen before we fired the second one. The first electron was alone in the universe of the experiment. It had nothing to interact with. It had no other electrons to bounce off of. So, how could it create an interference pattern? To create an interference pattern, a wave must pass through both slits at the same time, split in two, and then interfere with itself on the other side. But an electron is a single particle. It is a single chunk of matter. How can a single chunk of matter go through two doors at once? This is where your intuition begins to scream. This is where the logic of the real world dissolves into mist. The experiment suggests that the single electron, when fired, does not travel like a bullet. It dissolves into a ghost. It becomes a wave of probability. This probability wave travels toward the barrier. It goes through slit A. It also goes through slit B. It goes through neither. It goes through both. The ghost of the electron passes through both slits simultaneously, emerges on the other side, and interferes with itself. The ghost electron from slit A high-fives the ghost electron from slit B, creating a complex pattern of where it might end up. Only when it hits the back screen does it decide to become a solid particle again, appearing as a single dot. But that dot's location was determined by the interference of the ghost wave. This implies something terrifying. Before the electron hits the wall, it does not exist in a single location. It exists in a superposition of all possible paths. It is everywhere and nowhere. It is a cloud of pure potential. But you, being a skeptical human, might say, "This is impossible. I don't believe it. The electron must be going through one slit or the other, and we just aren't seeing it." So, we decide to cheat. We decide to spy on the electron. We place a tiny sensor, a measuring device, a quantum eye, right next to the slits. This sensor will beep if it sees the electron go through slit A, and it will beep if it sees the electron go through slit B. We are going to force the universe to tell us the truth. We are going to watch the ghost. We turn on the electron gun. We turn on the sensor. Click. An electron is fired. The sensor beeps. Slit A it says. We see the electron pass through slit A. We catch it in the act. Click. Another electron. The sensor beeps. Slit B. We see it pass through slit B. We are triumphant. We have proven that the electron is a particle. It is going through one hole at a time, just like a marble. We let the experiment run for an hour, watching every single electron, cataloging its path. We have restored order to the cosmos. Then we look at the back screen, and the blood drains from our faces. The interference pattern is gone. There are no alternating stripes. There are just two simple bands, exactly like the marbles. The beautiful, complex wave pattern has vanished. Do you understand what has happened? This is the moment that makes atheists pray and philosophers weep. The electron knew it was being watched. When we did not look, the electron behaved like a wave, fluid, ghostly, existing in multiple places at once, exploring all possibilities. But the moment we looked, the moment we demanded to know which path it took, the electron stopped behaving like a wave and snapped into behaving like a solid particle. It chose a path. It solidified. It abandoned its ghostly nature and played the role of the marble. The act of observation changed the reality of the particle. This is the observer effect, and it suggests that the universe is not a fixed, objective stage where events play out whether we are there or not. It suggests that the universe is a fluid, undefined potential that only snaps into a concrete reality when it is forced to interact with a measurement. When you close your eyes, does the world disappear? Maybe not, but the quantum world suggests that when you are not interacting with it, reality is fuzzy. It is a haze of maybe and could be. It is a superposition of infinite possibilities. It is only when you reach out and touch it, when you open your eyes and see it, that the universe collapses into the is. Think about the silence of a room you have just left. You imagine the furniture sitting there, solid and heavy. But quantum mechanics whispers that, perhaps, in the absence of any interaction, the atoms of that chair are slightly less chair-like. They are vibrating a little more freely, their positions a little less defined. The universe relaxes when we aren't looking. It unbuttons its collar. It dissolves into a dream. This revelation is terrifying because it implies a connection between the observer and the observed that we are not ready to accept. We want to be spectators. We want to be an audience watching the cosmic play. But physics tells us we are not the audience. We are the playwrights. Our gaze directs the action. The electron is not a little ball. It is a manifestation of possibility. And you, the observer, are the agent that forces possibility to become history. There is a famous thought experiment devised by the physicist Erwin Schrodinger to illustrate the absurdity of this. He imagined a cat locked in a steel box with a tiny amount of radioactive substance, a Geiger counter, and a vial of poison. If a single atom of the substance decays, the counter detects it and smashes the vial, killing the cat. According to quantum mechanics, until you open the box to check, the atom has both decayed and not decayed. It is in a superposition. Therefore, the vial is both broken and unbroken, and therefore the cat is both dead and alive. Schrodinger did not propose this because he believed in zombie cats. He proposed it to show how ridiculous it is to apply quantum rules to everyday objects. A cat cannot be both dead and alive. It is one or the other. But the math of quantum mechanics does not agree. The math says that until the box is opened, until the measurement is made, the two realities exist simultaneously. The universe holds its breath. So, who opens the box? You do. Every moment of your life is the opening of a box. Every time you blink, you are collapsing a wave function. Every time you make a decision, you are forcing the universe to choose a path. You are walking through a fog of probability, and with every step, the ground solidifies beneath your feet, just in time to catch you. Behind you, the path may very well dissolve back into the mist. This might sound liberating to some. The idea that we create our reality, but in the quiet of the night, it is a heavy burden. It means there is no out there that is independent of in here. The cold, distant stars are not just burning balls of gas ignoring you. Their light travels for millions of years in a wave of probability, spreading out across the cosmos until it hits your retina. In that moment, and only in that moment, does the photon decide to land on your eye. You are the destination that defines the journey. As we end this chapter, consider the space around you again. The air is filled with radio waves, Wi-Fi signals, cellular data, invisible waves carrying information, passing through your body. Right now, they are ghost waves. They only become music or pictures or voices when a device, an observer, catches them and collapses them into a signal. You are the ultimate device. You are the conscious observers standing in the center of the storm. The universe is a swirling chaos of quantum foam, a terrifyingly unstable ocean of infinite potential, and you, your mind, your perception, are the anchor. You are the rock that forces the ocean to be still. Without you, the universe might just be a ghost story telling itself to no one. It might be a symphony with no one to hear it, and therefore a symphony that makes no sound. But if the mere act of watching an electron can change its behavior from a wave to a particle, what happens when we zoom out? What happens when we realize that particles can be connected to each other across vast distances instantaneously, defying the speed of light? What happens when the ghost in the machine isn't just in the machine, but is the machine itself? Rest your mind now. The chair is solid because you are sitting in it. The room is here because you are seeing it. You have collapsed the wave function of this moment. You are safe in the reality you have summoned. But tomorrow we will explore the thread that connects you to the other side of the galaxy, a thread that Einstein called spooky action at a distance. We will learn that separation is an illusion, just like solidity. Sleep well, observer. The universe is waiting for you to wake up so it can exist again. Have you ever felt truly alone? It is a cold, hollow feeling that settles in the chest. You look out at the night sky, at the stars burning in the silent vacuum, and you feel the crushing weight of distance. Those points of light are trillions of miles away. The person sitting in the room next to you is separated by walls and air. Even in a crowd, even in the arms of a lover, there is a boundary, your skin, your mind, your singular experience that seems to wall you off from the rest of existence. We live our lives convinced that we are islands. We believe that what happens here, inside our own bodies and lives, is distinct from what happens there, on the other side of the room, or the other side of the planet, or the other side of the galaxy. This belief in separation is the foundation of our loneliness. But what if I told you that distance is an illusion? What if I told you that space, the vast empty stage that seems to separate the actor from the audience, the sun from the earth, and you from me, is not a barrier at all? What if, at the deepest level of reality, here and there are exactly the same place? In the last chapter, we discovered that looking at the universe changes it. Now, we must grapple with something even more unsettling. The fact that the universe seems to be stitched together by invisible threads that ignore the laws of space and time entirely. We are entering the realm of quantum entanglement, a phenomenon so bizarre that Albert Einstein himself refused to believe it could be the whole truth. He mocked it. He called it spooky action at a distance. He went to his grave, hoping there was a hidden mistake in the math that would make the universe make sense again. But there was no mistake. The spooky action is real. And it suggests that you have never actually been separated from anything. To understand this, we must return to our quantum playground. Imagine we have a special machine that creates particles, let's say electrons, in pairs. But these are not just any pair of electrons, like two strangers meeting on a bus. These are born together from the same burst of energy. They are twins, linked by the laws of conservation. In the quantum world, particles have a property called spin. It is not exactly spinning like a spinning top. Remember, quantum objects are ghosts, not balls. But for the sake of our poor human brains, we can imagine them spinning. An electron can spin up or it can spin down. Now, here is the rule. Because these two electrons were born together as a pair with a zero total spin, their spins must cancel each other out. If one is spinning up, the other must be spinning down. It is a cosmic law. The balance must be kept. This sounds simple enough. If I have a pair of gloves, and I put the right glove in a box and mail it to you, and I keep the left glove, I know instantly that if I am holding the left glove, you must have the right one. That isn't spooky. That is just logic. But quantum mechanics is never just logic. Remember the lesson of the double slit. Until you look, the particle is in a superposition. It is not up or down. It is both up and down at the same time. It is a spinning cloud of probability. So, we take our two entangled electrons. We keep one here on Earth. Let's call it electron A. We put the other one, electron B, onto a spaceship and send it to the Andromeda Galaxy, 2.5 million light years away. For 2.5 million years, electron B travels through the silent void. Electron A sits in a lab on Earth. Neither of them has a defined spin. Both of them are shimmering in a superposition of up and down. They are not two separate objects anymore. They are a single quantum system stretched across an unimaginable abyss. Now, the moment of truth. You, the scientist on Earth, decide to measure electron A. You set up your detector. You force the ghost to decide. The universe holds its breath. You look. Click. Electron A snaps into reality. It is spinning up. Here is the terror. At that exact instant, not a second later, not a millisecond later, but instantaneously, electron B in the Andromeda Galaxy snaps into reality. It becomes down. There was no time for a signal to travel between them. Light would take 2.5 million years to cross that distance. A radio wave, a text message, a beam of energy. Nothing could travel fast enough to tell electron B that its partner had been measured. And yet, electron B knew. Across the vast, freezing ocean of intergalactic space, the connection was immediate. It is as if the 2.5 million light years of space did not exist. It is as if the two particles were right next to each other, whispering secrets in the dark. Einstein hated this. He argued that nothing can travel faster than the speed of light. It is the cosmic speed limit, the absolute law of the universe. If information could travel instantly, it would break the concept of cause and effect. It would mean the universe was chaotic, lawless, magical. He argued that there must be hidden variables, secret instructions written inside the particles from the start. that determined their spin before they ever left the lab, like the gloves in the boxes. But decades later, a physicist named John Bell came up with a way to test this, and in laboratories around the world, from Switzerland to the Canary Islands, the experiments have been run. The results are undeniable. Einstein was wrong. There are no hidden variables. The gloves are empty until you look at them, and the connection is instantaneous. This phenomenon, non-locality, tears apart our intuitive map of reality. We navigate the world using coordinates. I am here at this longitude and latitude. You are there. We are separated by meters or miles. To affect you, I must cross that distance. I must walk to you, or throw a rock, or shout, or send a signal. The influence must travel through the intervening space. But entanglement says that for quantum systems, space is irrelevant. Distance is a formality. Two entangled particles are not two separate things separated by space. They are one thing that happens to be in two places. Let that sink in. One thing in two places. If we apply this to the grand scale of the cosmos, the implications become spiritual, almost hallucinogenic. Think back to the beginning of everything. The Big Bang, 14 billion years ago, the entire known universe. Every star, every planet, every ocean, every atom in your body, and every atom in the most distant nebula was crushed into a single point of infinite density, a singularity. In that first moment of creation, everything was touching. Everything was interacting. Everything was entangled. Then the explosion, the great expansion. The universe blew outward, stretching faster than the mind can comprehend. Matter cooled, condensed, and drifted apart. Clouds formed stars, stars forged elements, elements formed planets, and planets birthed life. You are sitting here, reading this, composed of atoms that have traveled through eons of cosmic history. But if quantum mechanics holds true, and if entanglement is a bond that distance cannot break, then are we ever truly separated from the source? If the atoms in your right hand were once entangled with the atoms that now make up a stone on Mars, or a gas cloud in the Orion Nebula, is that connection still there? Is there a faint, ghostly thread of wave function that still binds you to the rest of the cosmos? Some physicists argue that entanglement is fragile, that it breaks easily when particles interact with the hot, messy environment of the real world. This is called decoherence. It is why you don't see people teleporting or walking through walls. The quantum magic gets washed out by the noise of trillions of atoms bumping into each other, but the fundamental connection remains a theoretical possibility. The universe might not be a collection of trillions of separate objects. It might be a single, vast, incredibly complex wave function. One giant quantum object, expanding and breathing, fooling itself into thinking it is many things. When you look at another person, you're looking at a surface. You see skin, eyes, hair. You see a them. But underneath the surface, in the quiet hum of the quantum foam, the particles that make up that person and the particles that make up you might be dancing in a synchronized rhythm that defies the space between you. You are not an observer looking at the universe from the outside. You are a ripple in the ocean looking at another ripple. The water is the same. The separation is just a shape the water has taken for a brief moment. This dissolves the very concept of aloneness. You cannot be alone if you are physically, fundamentally woven into the fabric of everything else. The feeling of isolation is a biological trick, a necessary illusion for survival. If you felt your connection to every atom in the universe, you would cease to function as a human being. You would dissolve into the infinite. So your brain filters it out. It creates a self and an other. It creates here and there. Sure, it creates the quiet room and the distant stars. But the physics suggests that the filter is lying. Consider the birds that navigate by sensing the Earth's magnetic field. Recent biology suggests that European robins might use quantum entanglement in their eyes to see magnetic field lines. A chemical reaction inside their retinas creates entangled pairs of electrons. As the bird flies, the Earth's magnetic field affects these electrons, changing the chemical signals sent to the bird's brain. The bird is literally surfing on a quantum wave, connected to the planet's magnetic heart by the spooky action of entanglement. If a bird can harness this connection, what is happening in the wet, warm, complex network of your own brain? Are your thoughts purely electrical impulses traveling along neurons? Or is there a deeper, quantum layer to consciousness? Some rogue scientists have dared to ask if consciousness itself might be a quantum phenomenon. If the mind is not just a machine made of meat, but a resonance of quantum states, then perhaps our minds are not trapped in our skulls. Perhaps, through entanglement, we are touching the minds of others in ways we cannot measure with our crude tools. Perhaps intuition, that sudden feeling of knowing something you cannot know, is just the flicker of an entangled thread vibrating across the distance. We are venturing into speculation here, drifting from the hard shore of proven science into the mist of hypothesis. But the hard science is strange enough on its own. The hard science says that reality is non-local. It says that what happens in one corner of the universe can differ depending on what happens in another corner instantly. It says that the universe is holistic. It is a whole that cannot be fully understood by just looking at the parts. Imagine a book where the meaning of a word on page 1 changes instantly, depending on which word you read on page 500. You cannot understand the story by reading one page at a time. You have to read the whole thing at once. The universe is that book. As you sit in your chair, feeling the weight of your body, try to expand your awareness. Feel the space around you. It is not empty. It is a medium of connection. The light hitting your skin is a stream of photons that were entangled with electrons in the sun 8 minutes ago. The gravity holding you down is a curvature of space-time caused by the mass of the entire Earth interacting with the mass of your body. And deep down, in the cathedral of the atom, the electrons are spinning, up, down, dancing with partners they may have left billions of years ago. You are a knot in a cosmic web. The threads stretch out from your chest, passing through walls, through the atmosphere, through the vacuum, tying you to the heart of exploding stars and the frozen surface of distant moons. You are never untethered. You are never truly solitary. The terror of quantum mechanics is the loss of the self. It is the realization that you are not a discrete entity. You are a localized phenomenon in a unified field. To the ego, this is death. To the spirit, it is liberation. It means that when you die, you do not leave the universe. You cannot leave the universe. You are the universe. You are just changing your state of entanglement. The wave function that is you spreads out, decoheres, and merges back into the great, silent ocean of probability from which it arose. So, the next time you feel small beneath the night sky, remember the invisible threads. Remember that the light from those stars is not just falling on you, it is interacting with you. You are part of the same system. The universe is looking at itself through your eyes. And in doing so, it is deciding what it is. The distance is a lie. The separation is a dream. The silence is not empty. It is the hum of a connection so deep, so ancient, and so total that it requires no signal, no words, and no time. But if space is an illusion and separation is a myth, what about the most stubborn illusion of them all? What about time? We feel time flowing like a river, carrying us from the past into the future. We remember yesterday, but we cannot remember tomorrow. We believe the past is gone and the future is unwritten. But the quantum equations do not care about the direction of time. In the math of the universe, the future can affect the past just as easily as the past affects the future. Sleep now, connected one. Rest in the web of stars. Tomorrow we will pull on the thread of time itself, and we might find that tomorrow has already happened, and yesterday is still waiting to be born. Have you ever wished you could turn back time? It is a universal human longing. We replay the mistakes of yesterday in our minds, rewriting the script, imagining what we would have said, what we would have done, if only we knew then what we know now. We view time as a relentless, one-way river. It carries us from the fixed, unchangeable mountains of the past through the fleeting valley of the present, toward the misty, unwritten ocean of the future. We believe that the past creates the present, and the present creates the future. Cause comes before effect. The arrow of time flies in only one direction. This belief is the architecture of our regret and the foundation of our hope. But what if I told you that the arrow of time is a hallucination? What if the future is not a misty ocean waiting to be filled, but a solid landscape that already exists? And even more terrifying, what if the choices you make tomorrow can reach back and rewrite the history of yesterday? We are entering the strangest room in the quantum house, the room where time dissolves. To understand this, we must first look at the equations that govern the universe. If you look at the math of Newton, or the math of Maxwell, or even the math of Schrodinger, you will notice something peculiar. There is no forward or backward in the equations. They work equally well in both directions. If you filmed a collision between two billiard balls and played it backward, it would look perfectly natural. The laws of physics do not care about this sequence of events. At the fundamental level, an atom does not know that time is supposed to move forward, but we see time moving forward because of entropy, the tendency of things to get messy. A cup breaks and does not put itself back together. An egg scrambles and does not unscramble. This gives us the illusion of an arrow, but this is a statistical probability, not a fundamental law. And when we look at individual quantum particles, even this arrow disappears. There is an experiment that breaks the human mind. It is called the delayed choice quantum eraser. It was first proposed by John Wheeler, a giant of physics, and later performed in reality. It is a variation of the double slit experiment we discussed before, but with a twist that seems to violate the basic rules of chronology. Remember the double slit? If we don't look, the electron goes through both slits as a wave. If we do look, it goes through one slit as a particle. The act of measurement determines the reality. Now, imagine we make the experiment much more sophisticated. We fire a photon, a particle of light, at the double slit. After it passes through the slits, either as a wave or a particle, we use a special crystal to split that photon into two entangled twin photons. Let's call them the signal photon and the idler photon. The signal photon goes straight to a detector screen. Its journey is short. It hits the screen and leaves a mark. The idler photon, however, is sent on a longer journey. It travels through a maze of mirrors and fiber optic cables. It travels for a long time, long after the signal photon has already hit its screen and died. Here is the setup. We can choose to measure the idler photon, or we can choose to ignore it. If we measure it, we know which path it took. Because it is entangled with the signal photon, knowing the idler's path tells us the signal's path. If we ignore it, if we erase the information, we know nothing. But remember, the idler photon reaches its decision point after the signal photon has already hit the screen. In human terms, the signal photon arrives at 12:00 p.m. The idler photon reaches our detector at 12:01 p.m. So, at 12:00 p.m., the signal photon hits the screen. It has to decide right then, am I a wave creating an interference pattern, or am I a particle creating a single clump? Logic dictates that it cannot know what we are going to do at 12:01 p.m. It cannot know if we will measure its twin or let it go unmeasured. It is stuck in the past, but the experiment shows the impossible. If, at 12:01 p.m., we decide to measure the idler photon, forcing it to be a particle, the signal photon back at 12:00 p.m. will have already formed a particle pattern. If, at 12:01 p.m., we decide to erase the information, allowing it to remain a wave, the signal photon back at 12:00 p.m. will have already formed a wave pattern. Read that again. The decision we made in the future determined the shape of the past. The signal photon, sitting on the screen in the past, seemingly waited for us to make up our minds in the future before deciding what it had always been. Or, more disturbingly, our choice in the future reached back through time and collapsed the wave function of the past. This suggests that history is not written in ink. It is written in pencil. And until the final observation is made, the pencil marks can be rubbed out and rewritten. The events of yesterday are not fixed stones. They are quantum echoes waiting for the tomorrow that defines them. This creates a sensation of vertigo. It implies that the universe is not a sequence of events unfolding one by one, like dominoes falling. Instead, the universe is a singular block of space-time, where the past, present, and future are all entangled, all affecting each other simultaneously. Einstein called this the block universe. Imagine a loaf of bread. You can slice it anywhere you want. One slice is now. The slice behind it is yesterday. The slice ahead is tomorrow. But the whole loaf exists at once. The dinosaur stepping into the mud millions of years ago, you reading this sentence right now, and the sun expanding to swallow the earth billions of years from now. They are all just slices of the same existing loaf. From the perspective of a photon, time does not pass at all. According to relativity, as you approach the speed of light, time slows down. At the speed of light, time stops. To a photon traveling from a distant star to your eye, the journey takes 0 time. It is born in the star and dies on your retina in the same instant. For the light, there is no distance and no duration. The emission and the absorption are a single event. This means that when you look at the stars, you are not just looking back in time. You are participating in an interaction that spans the cosmos instantly. The star knows you are watching it, because your eye is the bucket that catches the rain of light. But let us bring this back to the terror of the delayed choice. If the future can affect the past in a laboratory, does it happen in the messy macro world of human lives? We like to believe we have free will. We believe we stand at the fork in the road and choose our path. But if the block universe is real, the path is already laid. The future you, the one who is 10 years older, the one who has already made the choices, is just as real as the you sitting here. That future self is already there, down the road, waiting for you to catch up. Does this mean we are puppets? Or does it mean something deeper? Perhaps our sensation of the flow of time is just our consciousness crawling across the static map of eternity. We are like a spotlight moving across a dark painting. The painting doesn't change. Only the part we can see changes. This view changes the nature of death. If the past is just as real as the present, then nothing is ever truly lost. The child you were is not gone. They are simply down the block. The loved ones who have died are not erased. They are existing eternally in the slice of space-time they occupied. They are safe in the amber of the universe. But the quantum retrocausality adds a ghostlier layer. It suggests that your current actions might be influencing not just your future, but refining the probabilities of your past. Maybe the intuition you feel, the gut instinct that warns you of danger, is not a memory of the past, but a memory of the future. Maybe it is the idler photon of your life, sending a ripple back to the signal photon of your present. In this model, the universe is a self-consistent loop. It is a snake eating its own tail. The end informs the beginning, and the beginning necessitates the end. This is a quiet, heavy thought to hold in the dark. It strips away the anxiety of what will happen, because in a sense, it has already happened. The wave function of your life is spreading out, exploring all paths. But the measurement, the final reality, is a negotiation between the beginning and the end. As you sit here, breathing in and out, you are a time machine. Your body is aging, moving forward through the entropy of the macro world. But your atoms are timeless. They are dancing in a quantum realm where before and after are meaningless labels. The terror here is the loss of control. We want to be the drivers of the car, steering toward a destination we choose. But physics suggests the road was built long before we started the engine, and the destination might have determined the starting point. Yet, there is beauty in this fatalism. It suggests a coherence to reality. It suggests that things happen for a reason, not for a mystical reason, but for a physical necessity. The future requires the past to be a certain way, so the past complies. The universe is a perfect puzzle where every piece, from the first second of the Big Bang to the last second of heat, death, fits together in a way that cannot be otherwise. You are a necessary part of that puzzle. You are not a random accident drifting through time. You are a bridge between the past and the future, a structure of space-time that had to exist exactly as it does for the universe to be complete. So, when you worry about the future, remember the delayed choice. Remember that the story is being written from both ends at once. The anxiety you feel about a future event might be the shadow of that event casting itself backward upon you. And if time is an illusion, if the now is just a slice of the loaf, then where does that leave the concept of possibility? If the block is solid, is there only one future? Here, the quantum physicist smiles a tired, enigmatic smile, because there is another interpretation, one that solves the paradox of the collapsed wave by suggesting that the wave never collapses, one that says every time you make a choice, you don't select one future, you create two. In the next chapter, we will walk through the door of the many worlds interpretation. We will look at the version of you that didn't read this article. We will look at the version of you that turned left instead of right. We will confront the possibility that you are infinite and that every tragedy and every triumph you have ever imagined is actually happening right now, in a room just beside this one. Sleep now, time traveler. The past is safe. The future is waiting, and the present is the only place where you can feel the breathe of the universe on your neck. Have you ever stood at a crossroads, physical or metaphorical, and felt the heavy, crushing weight of a choice? Perhaps it was something small, like deciding whether to turn left toward the coffee shop or right toward the park. Perhaps it was something monumental, like choosing a university, accepting a marriage proposal, or quitting a job. You make the choice. You walk down one path, and as you do, the other path fades into the mist of what might have been. You look back, and you see only the road you traveled. The other road, the unchosen one, ceases to exist. It becomes a phantom, a figment of your imagination, a regret that haunts you in the quiet hours of the night. You tell yourself that you only have one life, one timeline, one singular story written in the ink of your decisions. But what if the ghost of the road not taken is just as real as the ground beneath your feet? What if, at the exact moment you turned left, another version of you, just as real, just as terrified, just as hopeful, turned right? What if the universe did not force you to choose, but instead, quietly and seamlessly, split itself in two to accommodate both possibilities? We have arrived at the most dizzying, controversial, and beautiful idea in the history of quantum mechanics, the many worlds interpretation. In the previous chapters, we wrestled with the Copenhagen interpretation, the standard view of quantum mechanics taught in universities for nearly a century. This view tells us that the wave function, that shimmering cloud of probability, collapses when we look at it. The electron is everywhere at once, but when we measure it, it magically snaps into one position. The cat is dead and alive, but when we open the box, nature flips a coin and chooses one fate. But there is a deep, ugly scar in this theory. It is the measurement problem. Why does the wave collapse? What is special about measurement? Does the universe require a conscious human with a PhD to look at an atom for it to become real? Does a camera count? Does a fly count? The math of quantum mechanics doesn't actually contain a collapse. The equation Schrodinger wrote down, the equation that governs the wave function, is smooth, continuous, and deterministic. It says the wave should keep flowing forever. It never says, stop and become a particle. Physicists just added that part in because it matched what we saw. It was a Band-Aid, a cheat code. In 1957, a graduate student at Princeton named Hugh Everett III decided to remove the Band-Aid. He looked at the math and asked a simple, terrifying question. What if the wave function never collapses? What if the electron, when faced with the choice of going through slit A or slit B, actually does both? But, and this is the key, to do both, the universe itself must make space for both realities. Everett proposed that when a quantum event has multiple possible outcomes, all of them happen. But they happen in separate, mutually exclusive branches of reality. When you measure the electron, you don't force it to choose. Instead, you split. Imagine the universe is not a single line, but a vast, rapidly growing tree. At the base of the trunk is the Big Bang. As time flows upward, the trunk splits into branches. Every time a subatomic particle interacts with another, which happens trillions of times a nanosecond in every cubic inch of space, the universe branches. When you opened Schrodinger's box, you didn't kill the cat or save it. You became two people. There is a version of you who opened the box, found a dead cat, and is now grieving. There is another version of you sharing the exact same past up until that second, who opened the box, found a living cat, and is now relieved. These two versions of you are effectively ghosts to one another. They inhabit the same space and time, but they are vibrating at different frequencies, orthogonal to one another, unable to interact, see, or hear each other. They are like two radio stations playing different songs in the same room. The air is full of both songs, but your radio is tuned only to one. The other song is there, right now, vibrating against your skin, but you cannot hear it. This is the many worlds interpretation, and if it is true, the word universe is too small. We live in a multiverse. The implications of this are so vast that they shatter the human ego completely. It means that there is no such thing as a unique you. You are a multiplicity. You are a choir. Think of a moment in your past where you almost died. Maybe you were driving and a car swerved into your lane, missing you by inches. You felt the adrenaline spike, the cold sweat, the relief. You drove home, shaken, and told your family, "I was almost killed." In the many worlds view, you were killed. In a branch of reality that split off a fraction of a second before the swerve, the cars collided. That version of you died. The version of you that is reading this now is the survivor, the one who exists in the branch where the steering wheel was turned just enough, where the friction of the tires held just enough. You are the winner of a quantum lottery that you didn't even know you were playing. This leads to a thought experiment known as quantum immortality. It is a dark and logical extension of Everett's theory. If consciousness is a continuous experience, you can only experience the branches of the universe in which you are alive. You cannot experience a branch where you are dead because there is no you there to experience it. Therefore, from your own subjective perspective, you might never die. Every time you face a lethal quantum event, your consciousness will naturally find itself in the branch where the gun jammed, where the cancer went into remission, where the car missed. You would watch everyone around you die, aging and fading in your timeline, while you remain, impossibly lucky, stranded in a statistically unlikely branch of survival. It is a lonely kind of immortality, a survival of the fittest where the only fitness is the ability to exist. But let us step back from the edge of that abyss and look at the beauty of the multiverse. If many worlds is true, it means that every regret you hold is unnecessary. Did you regret not taking that art class in college? Somewhere, in a branch that split off 20 years ago, you took it. You became a painter. You are standing in a studio right now, smelling of turpentine and linseed oil, looking at a canvas. That version of you is just as real as the one sitting here. Did you regret the words you shouted in anger? Somewhere, you stayed silent. You swallowed the anger. The relationship was saved. The multiverse is a library of all possible lives. It is a garden of infinite forking paths. Everything that can happen does happen. The universe is not a cruel editor that deletes the scenes it doesn't like. It is a boundless creator that writes every possible draft of the story simultaneously. This changes the nature of coincidence. We marvel when we run into an old friend in a foreign city, or when we guess a password correctly on the first try. We call it fate. We call it a miracle. But in the multiverse, these things are inevitable. There are trillions of branches where you didn't run into that friend. There are trillions where you guessed the wrong password. You just happen to be the version of you in the branch where the rare event occurred. You are the surfer riding the one wave out of a billion that happened to break perfectly. But this brings us to a terrifying question of scale. How many worlds are there? The number is not just big, it is not even astronomical. It is a number so large that if you wrote a 0 on every atom in the observable universe, you wouldn't even have written the first tiny fraction of the number. The universe splits not just when you make a decision, but every time an electron shifts its energy state, every time a photon hits a leaf, every time a neutron decays. In the time it took you to read this sentence, the universe has branched into more versions of history than there are grains of sand on all the beaches of all the planets in all the galaxies of the cosmos. You are not walking a single tightrope through time. You are walking across a rapidly expanding fractal. You are shattering into infinity with every heartbeat. This sensation of shattering can feel chaotic. It can make life feel weightless, as if nothing matters, because everything happens anyway. If I commit a crime in this world, and I am a saint in another, does my morality matter? But there is another way to look at it. It gives weight to the now, because even though there are infinite versions of you, there is only one version of you that is conscious of this specific moment. The connection between your memories, your current sensation, and your immediate future is the thread you are responsible for. You are the custodian of this specific branch. You are the gardener of this specific reality. The silence of the room you are in is deceptively full. It is crowded with the invisible, intangible ghosts of the worlds you just left. Physicists have tried to prove or disprove this theory for decades. It is difficult because, by definition, the other worlds are inaccessible. We cannot call the other version of ourselves on the phone. The decoherence, the separation of the branches, is absolute. Once the split happens, the bridge is burned. The worlds drift apart in the high-dimensional space of the wave function called Hilbert space, never to touch again. However, some theoretical physicists believe we might be able to detect the bruise of another universe bumping against ours. They look at the cosmic microwave background, the afterglow of the Big Bang, for cold spots or strange patterns that might be the gravitational shadow of a neighboring branch. So far, the evidence is inconclusive. We are left with the math, which insists that the splitting is real, and our intuition, which screams that it cannot be. But remember, our intuition evolved to help us hunt gazelles on the savannah, not to understand the architecture of hyperspace. Our intuition tells us the Earth is flat. Our intuition tells us the sun goes around the Earth. Our intuition is frequently wrong. The many worlds interpretation also solves the paradox of time travel we discussed in the last chapter. If you go back in time and kill your grandfather, you don't cease to exist. You simply create a new branch. There is a branch where your grandfather lived and you were born, and a new branch where he died and you were never born. You, the time traveler, are now stranded in the second branch, a refugee from a timeline that is no longer accessible from here. The paradox dissolves. The loop opens into a fork. There is a profound loneliness to the many worlds, but also a profound companionship. It means you are never truly alone in your struggles. In the infinite variations of reality, every pain you feel has been felt by a version of you who overcame it. Every problem you face has been solved by a version of you who found the answer. You are part of a vast team of selves, exploring every nook and cranny of existence. As you sit here, you are the tip of a spear that is thrusting into the future. But you are not a single spear. You are one tip of an expanding sphere of spears, pushing into the dark in all directions. The chair you sit on exists in all these worlds, but in some it has broken, in some it was never made. In some, humanity never evolved to build chairs. The fact that you are sitting here in a stable world reading about quantum physics implies that you are in a very specific, highly ordered, and incredibly fortunate branch of the wave function. You are riding a miracle of stability through a chaotic storm of infinite possibilities. And what keeps these worlds apart? What prevents the ghosts from bleeding through? It is the rigidity of the laws of physics. It is the very solidity we questioned in Chapter 1. The reason you don't see the other worlds is the same reason you don't fall through the floor. The forces of nature are keeping the boundaries distinct. But what if those boundaries aren't as stable as we think? We have talked about empty space, about particles that are waves, about connections that defy distance, about time that flows backward, and about universes that split endlessly. But there is one final monster lurking in the equations. It is a monster that hides in the very concept of nothing. We tend to think of a vacuum, of empty space, as zero. No energy, no matter, just the void. But quantum mechanics tells us that zero is not really zero. The vacuum is seething with energy. It is a bubbling soup of virtual particles appearing and vanishing. And here is the terror. What if the zero we are living in isn't the true zero? What if the empty space of our universe is like a ball resting on a ledge, thinking it is on the ground, when the true ground is 1,000 miles further down? What if the vacuum of our cosmos is a false vacuum? If that is true, then at any moment, at any point in space, the floor could drop out. A bubble of true vacuum could form, and this bubble would expand at the speed of light, rewriting the laws of physics, deleting matter, deleting chemistry, deleting the many worlds, deleting the entanglement, deleting the very structure of the atom. It would come without warning. It would be faster than pain. It would be the ultimate silence. In the next chapter, we will stare into the void. We will ask if the stability of the universe is a permanent state, or if we are walking on a sheet of ice that is much, much thinner than we dare to imagine. We will explore the false vacuum decay, the catastrophe that could end the multiverse in a heartbeat, and why the sheer fact that we are here to discuss it might be the strangest statistic of all. Sleep well, traveler of the infinite branches. Your other selves are sleeping too, in bedrooms you will never see, dreaming dreams you will never know. But you are the one who is here. You are the one who is conscious of this line of text, and that makes you the center of your own infinity. Have you ever walked across a frozen lake in the dead of winter? You step out onto the ice, and it feels solid beneath your boots. It is hard, white, and seemingly permanent. You know, intellectually, that there is deep, cold water beneath you, but the ice is thick enough to hold your weight. You feel safe. You build a fire. You pitch a tent. You live your life on this frozen plain. You trust the ice. You trust that the state of the water has settled into this solid form and will remain that way. You assume that ice is the final answer to the question the water was asking. But what if the ice you are standing on is not the bottom? What if it is just a thin crust over an abyss that goes down forever? We have spent the last few chapters deconstructing the objects in the universe, the chair, the atom, the electron, the timeline. Now, we must deconstruct the stage itself. We are going to talk about the stability of the vacuum, the invisible energy field that dictates the rules of reality, and the terrifying possibility that the laws of physics themselves are just a temporary accident. To understand this, we must introduce you to a character that has been hiding in the shadows of physics for decades, only revealing its face in 2012 at the Large Hadron Collider in Geneva. It is called The Higgs field. Imagine the universe is filled with a thick, invisible syrup. This syrup permeates every inch of space, from the inside of your atoms to the vast voids between galaxies. As particles move through this syrup, they feel a drag. They get heavy. This drag is what we call mass. If the Higgs field did not exist, electrons would zip around at the speed of light, refusing to bond with nuclei. Atoms would not form. You would not exist. The universe would be a soup of radiation screaming through the dark. The existence of the Higgs field is what allows the universe to be solid. It is the reason you have weight. It is the reason the chair holds you. It is the bedrock of our material existence. But here is the catch. Fields have energy states. Think of a ball rolling down a hill. The ball wants to get to the bottom, to the point of lowest energy. When it reaches the bottom of the valley, it stops. It is stable. It is at peace. For billions of years, physicists assumed that the Higgs field was at the bottom of the hill. We assumed it had settled into its true vacuum state, the lowest possible energy level. We assumed the ice we are standing on is resting on the solid ground of the lake bed. But when we measured the mass of the Higgs boson, the particle that tells us about the field, we found a number that made the blood run cold in the veins of theoretical physicists. The mass was approximately 125 giga-electron volts. This specific number suggests that the Higgs field is not at the bottom of the hill. It suggests that the ball rolled down the hill, but it got stuck in a little dip, a small valley halfway down the slope. It is resting on a ledge. Below this ledge, there is a sheer drop, a cliff that leads down to a much, much lower valley, the true vacuum. This means that our universe is metastable. We are not in the lowest energy state. We are in a false vacuum. We are living on a shelf of ice that is hanging over a cliff. Why is this terrifying? Because of the quantum rules we have already learned. Remember tunneling? Remember that particles can pass through barriers as if they weren't there. The Higgs field is a quantum object. It is jittering. It is fluctuating. For 13.8 billion years, it has stayed in the little valley of the false vacuum. It has been stable enough to allow stars to form and life to evolve. But it is not perfectly stable at any moment. In any random point in the universe, the Higgs field could tunnel through the barrier. The ball could slip over the edge of the ledge. If this happens, even at a single microscopic point, it triggers a chain reaction. The energy released by the field falling to the true vacuum would push the surrounding field over the edge too. A bubble would form. Inside this bubble, the Higgs field would be at the new, lower energy level. The laws of physics inside the bubble would be completely different from the laws outside. The constants of nature, the strength of gravity, the charge of the electron, the mass of particles, would be rewritten instantly. Chemistry, as we know it, relies on the current values of these constants. Inside the bubble of true vacuum, atoms might not be able to hold together. Matter might dissolve. Or perhaps gravity would become so strong that everything would collapse into black holes, or so weak that everything would fly apart. We simply do not know what the physics of the true vacuum looks like, only that it is incompatible with life. This bubble of doom is not a slow-moving thing. It is not a storm you can see coming on the horizon, because it is an expansion of pure energy. The wall of the bubble moves at the speed of light. Let that sink in. The speed of light. This means you would never see it coming. Light carries information. If the sun exploded right now, we would not know for 8 minutes. We would see the sun shining happily in the sky while the explosion traveled toward us. The death would arrive at the exact same instant as the news of the death. If a bubble of true vacuum nucleated 1 billion light-years away, it would expand outward, devouring galaxies, erasing stars, rewriting the cosmos. It could be rushing toward us right now. It could be halfway across the Milky Way. It could be inside our own solar system. We would look up at the sky and see the stars shining. We would feel the ground beneath our feet. We would take a breath, and then nothing. There would be no pain. There would be no fear. The nerve impulses that carry the sensation of pain travel much slower than the speed of light. Your brain would be disassembled into its fundamental quantum components. Before the electrical signal from your eyes could even reach your visual cortex, you would simply cease to be part of this universe. This is the vacuum decay. It is the ultimate cosmic silence. It is the realization that the universe itself might be a terminal patient, waiting for a sudden, inevitable collapse. It makes all our other worries seem incredibly small. We worry about climate change, about asteroid impacts, about the heat death of the universe trillions of years in the future. But vacuum decay is a guillotine blade that could fall at any second, without warning, without mercy, and without remedy. However, before you succumb to total despair, we must look at the probabilities. The universe has been here for nearly 14 billion years. The Higgs field has been sitting on that ledge for a very long time. It has withstood the violent collisions of black holes, the explosions of supernovae, and the intense energy of the early cosmos. It has not fallen yet. Calculations suggest that the lifetime of our metastable vacuum is likely extremely long, perhaps longer than the current age of the universe. It might take 10 to the power of 100 years for a bubble to form. We are likely safe, but likely is not certainly. And in the quantum world, anything that has a non-zero probability, given enough time, will eventually happen. There is a strange beauty in this fragility. It forces us to confront the fact that existence is not a right, but a privilege. The fact that the laws of physics have remained constant long enough for you to be born, to learn to read, and to understand this concept is a statistical miracle. We are walking on a tightrope over an infinite abyss. The rope is vibrating, the wind is blowing, and yet we are here. We are balancing. We are dancing. This knowledge changes the flavor of the now. If the future is not guaranteed, not just in the sense of I might die, but in the sense of the future itself might not exist, then the present moment becomes infinitely precious. The coffee you are drinking, the warmth of the blanket, the sound of your own breathing, these are not mundane details. They are victories against the void. They are rare, stable configurations of energy in a universe that is fundamentally unstable. Every second that passes without the vacuum decaying is a gift. Every heartbeat is a reprieve. Some physicists speculate that perhaps this has already happened elsewhere. Maybe the universe is vast enough that bubbles of true vacuum have already formed, billions of light years beyond our observable horizon. Maybe they are expanding right now, eating up distant, uninhabited regions of the cosmos. Since the universe is expanding faster than light, these bubbles might never catch up to us. We might be running away from the edge of the cliff just fast enough to survive. Or perhaps we are the only bubble of false vacuum left in a sea of true vacuum. Perhaps our universe is just a tiny pocket of warmth that hasn't frozen yet. This idea connects back to the many worlds theory. Maybe in the vast majority of branches of the multiverse, the vacuum did decay. Maybe life never formed there. Maybe we are only conscious in this branch because it is one of the few branches where the vacuum held together. We are the survivors of a cosmic game of Russian roulette that has been played trillions of times. The silence of the room takes on a new quality now. It is not just empty space. It is a tension. It is a held breath. The air around you is energized by the Higgs field, giving mass to your body, holding you together, but doing so with a tremulous hand. You're made of borrowed energy. You are a sculpture made of ice, and the temperature is rising. But let us step away from the cliff edge for a moment. Let us assume the vacuum holds. Let us assume the laws of physics keep their promise for another billion years. Even if the stage is stable, the actors are still mysterious. We have talked about the matter we can see, the atoms, the stars, the galaxies, but when astronomers look at the universe, they see something that doesn't make sense. They see galaxies spinning so fast that they should fly apart. They see light bending around invisible objects. They see a universe that is heavier than it looks. If you add up all the stars, all the gas, all the dust, all the planets, and all the black holes, it only accounts for 5% of the universe. 5%. Everything we have discussed so far, the quarks, the electrons, the photons, the cathedral of the atom, is just the foam on top of the ocean. The rest, the 95%, is dark. There is a ghost in the room with you, heavier than the walls, heavier than the earth. It passes through you right now, unnoticed, interacting with nothing but gravity. It is called dark matter, and there is a force pushing the universe apart, stretching the vacuum, fighting against gravity. It is called dark energy. The vacuum might be false, but the darkness is real. In the next chapter, we will turn off the lights and try to see what cannot be seen. We will explore the shadow universe that exists right on top of ours, the invisible skeleton that holds the galaxies together, and the mysterious energy that is ripping them apart. We will ask the question, if we are only 5% of reality, are we the main characters of this story? Or are we just the side effect of a much larger, darker drama? Rest now. The Higgs field is holding you. The bubble has not popped. The ice is holding. The laws of physics are still here. You have survived another second of eternity. Have you ever walked into a pitch-black room and felt a presence? You cannot see anything. You cannot hear anything. But the hair on the back of your neck stands up. Your primitive brain, inherited from ancestors who were hunted on the savannah, screams that you are not alone. You reach out a hand, waving it through the darkness, expecting to touch a wall or a person or a monster. You touch nothing but cool air. You convince yourself it is just your imagination. You tell yourself that if you cannot see it and you cannot touch it, it is not there. You turn on the light, the shadows flee, and the room is empty. You sigh with relief. The ghost was just a trick of the mind. But what if the ghost is real? What if the room is actually crowded, filled to the brim with invisible, intangible giants that dwarf you in size and mass? What if the empty air you waved your hand through is actually a dense ocean of matter that simply refuses to interact with the light of your lamp? In the previous chapters, we dismantled the solidity of the atom and the stability of time. Now, we must dismantle the pride of matter itself. We are going to look at the dark sector, the 95% of the universe that is hiding in plain sight. For centuries, astronomy was the study of light. We built telescopes to catch photons. We looked at the stars, the glowing gas clouds, the bright swirls of galaxies. We assumed that what we saw was what existed. We assumed that the universe was made of baryonic matter, protons, neutrons, electrons, the stuff that makes up you, me, the earth, and the sun. We thought the cosmos was a tapestry woven from light. But in the 1970s, an astronomer named Vera Rubin looked at the tapestry and noticed a thread was being pulled by an invisible hand. Rubin was studying the rotation of spiral galaxies. Imagine a merry-go-round. The children on the inner horses near the center spin relatively slowly. The children on the outer edge, near the rim, have to move much faster to keep up. But in a galaxy, gravity works like a tether. The gravity is strongest near the dense center, where most of the stars are. So, according to the laws of Newton and Einstein, the stars near the center should orbit quickly, while the stars at the lonely outer edges should drift lazily, like distant planets orbiting the sun. Rubin pointed her spectrograph at the Andromeda Galaxy and other spirals. She measured the speed of the outer stars. She expected to see them slowing down as they got further from the center. She did not see that. The stars at the edge were moving just as fast as the stars near the center. In fact, they were moving so fast, hundreds of thousands of miles per hour, that they should have been flung off into deep space. The visible gravity of the galaxy was not nearly enough to hold them. By all accounts, these galaxies should have torn themselves apart billions of years ago. They should be dissolving sprays of stars, not tight, beautiful spirals. It was as if the merry-go-round was spinning at 1,000 miles per hour, but the children were not flying off. Something was holding them, something invisible, something heavy. Rubin realized that for the galaxies to exist as they do, there had to be more mass than we could see. A lot more. In fact, there had to be 5 times more invisible matter than visible matter. This was the discovery of dark matter, and it changed our status in the universe instantly. We realized that the glowing stars and galaxies are not the main structure of the cosmos. They are just the Christmas lights strung up on a massive, invisible tree. We live in a halo of darkness. Right now, as you sit there reading, dark matter is passing through your body. It is streaming through the roof, through your skull, through the earth, and out the other side. It does not bump into your atoms. It does not reflect light. It does not absorb radio waves. It interacts only via gravity. It is a ghost in the truest sense, a substance that has mass and presence, but no electromagnetic footprint. If you could wear dark matter goggles, the night sky would change completely. The Milky Way, that faint band of light, would be revealed as a tiny, flattened disk embedded in the center of a colossal, spherical cloud of dark matter. This cloud extends far beyond the visible stars. It is the scaffolding of the galaxy. It is the womb that held the gas together long enough for stars to ignite. Without dark matter, the universe would be a diffuse mist. We owe our existence to a ghost. But knowing it is not the same as knowing what it is. Is it a new kind of particle? A WIMP, weakly interacting massive particle? Is it a swarm of primordial black holes? Is it a flaw in our understanding of gravity? We have built deep underground detectors, tanks of liquid xenon buried in gold mines, waiting for a single particle of dark matter to accidentally bump into an atom. We listen. We wait in the silence. But so far, nothing. The ghost refuses to speak. This invisible ocean makes us feel small. But the story gets darker, because while dark matter is holding the universe together, there is something else, something even more mysterious, that is tearing it apart. Let us travel back to 1998. 2 teams of astronomers were trying to weigh the universe. They were looking at distant supernovae, exploding stars to measure how fast the universe was expanding. Since the Big Bang, the cosmos has been growing, but everyone assumed that the growth was slowing down. Gravity is an attractive force. All the galaxies are pulling on each other. Logic dictates that the initial push of the Big Bang should be fighting against the gravity of all the mass in the universe. The expansion should be breaking. Eventually, it might even stop and reverse, leading to a big crunch. The astronomers measured the supernovae. They calculated the distances. They checked the data. They checked it again. They thought they had made a mistake. The data showed that the distant galaxies were not slowing down. They were speeding up. The expansion of the universe is accelerating. Imagine you throw a ball into the air. It goes up, slows down, stops, and falls back. That is gravity. Now, imagine you throw a ball into the air, and instead of slowing down, it shoots upward faster and faster, disappearing into the clouds. That is what our universe is doing. Something is pushing the galaxies apart. Something is creating new space between them. Something is overcoming the gravity of all the dark matter and all the visible matter combined. We call this force dark energy, and it is the most terrifying thing in the physics catalog because we have absolutely no idea what it is. It seems to be a property of space itself. As the universe expands, it creates more space. If dark energy is a property of space, then more space means more dark energy, and more dark energy pushes the universe to expand faster, which creates even more space, which creates even more dark energy. It is a runaway feedback loop of nothingness. If we look at the energy budget of the cosmos, the numbers are humbling. Dark energy makes up about 68% of the universe. Dark matter makes up about 27%. Normal matter, the stuff you, the earth, the sun, and the stars are made of, makes up less than 5%. Let that sink in. 5%. You are not the norm. You are the anomaly. You are the contamination. The universe is not a place made of atoms. It is a place made of dark energy and dark matter, with a light dusting of atoms sprinkled on top like glitter on a vast dark ocean. The Copernican principle states that we are not the center of the universe. We learned we are not the center of the solar system. Then we learned the sun is not the center of the galaxy. Then we learned the galaxy is not the center of the cosmos. Now we must accept the ultimate demotion. We are not even made of the primary substance of reality. We are the foam on the wave. But the true terror of dark energy lies in the future it predicts. Because it is accelerating the expansion, it is slowly isolating us. Right now, we can see billions of galaxies. Their light reaches us. But as the space between us and them stretches faster and faster, eventually, they will be moving away from us faster than the speed of light. Their light will try to reach us, but the space will act like a treadmill moving in the opposite direction. The light will never arrive. One by one, the distant galaxies will fade from the sky. They will slip behind the cosmic horizon. First, the most distant clusters will vanish, then the closer ones. Eventually, only the galaxies in our local group, the ones bound tightly by gravity, like Andromeda, will remain. The rest of the universe will go black. Future astronomers, billions of years from now, will look up and see only their own galaxy. They will see a static, dark void surrounding them. They will have no evidence of the Big Bang. They will have no evidence of the other galaxies. They will think the entire universe is just their one island of stars. They will be alone in the dark, with no way of knowing the vast, rich history that came before. We are living in a privileged time. We are living in the brief window of cosmic history where the light from the beginning is still visible, where the neighbors are still in view. We can see the truth of the expansion before the darkness hides it forever. But dark energy might have an even crueler fate in store. If the acceleration keeps increasing, if the force gets stronger, it leads to a scenario called the Big Rip. Billions of years from now, the repulsive force of dark energy could become strong enough to overcome the gravity of galaxy clusters. The clusters would fly apart. Then it would overcome the gravity of individual galaxies. The Milky Way would scatter. Then the force would enter the solar system. It would push the planets away from the sun. Earth would drift into the cold. Then it would overcome the gravity of the planet itself. Earth would explode. Then, in the final moments, the force would overcome the electromagnetic forces holding your atoms together. Your molecules would be ripped apart. Finally, the atoms themselves would be shredded. The universe would end in a singularity of total separation, where every particle is isolated from every other particle by an expanse of rapidly stretching space. This is the ultimate loneliness, not just the loneliness of a person in a room, but the loneliness of an electron that can never again feel the pull of a proton. However, the Big Rip is just one possibility. It depends on the exact nature of dark energy, which we do not understand. But the heat death, the slow, cold fade, is almost certain. As the universe expands, it cools. Stars burn out. New stars stop forming because the gas is too spread out. The lights go off. Black holes eventually evaporate. The universe becomes a sea of cold photons and lonely particles stretching forever into the dark. This is a heavy thing to contemplate on a Tuesday afternoon. It makes our daily struggles seem laughably insignificant. Why worry about a deadline when the galaxy is dissolving? Why worry about an awkward conversation when the universe is mostly invisible ghosts? But there is a strange comfort in the darkness, too. If 95% of the universe is dark, then the light is precious. The light is rare. You are made of the rare stuff. You are made of the stuff that can shine. Dark matter cannot love. Dark energy cannot create poetry. Only baryonic matter, only the 5%, has the complexity to form neurons, eyes, and hearts. Only the 5% can wake up and look at the darkness. We are the eyes of the universe. We are the only part of this vast dark machine that can see itself. The fact that we are small, the fact that we are outnumbered by the void, makes our existence even more defiant. Imagine a single candle burning in a cathedral the size of a solar system. The darkness is overwhelming. The cold is absolute. But the candle is burning. That is us. That is humanity. That is life. The darkness is not just an empty void. It is a womb. Dark matter held us together. Dark energy is opening the future, preventing the universe from crushing us in a big crunch. We are balanced between the pull of the ghost and the push of the void. And in that balance, we have found a place to stand. We have found a place to wonder. The silence of the dark sector is loud. It tells us that there is so much we do not know. We are like toddlers stumbling around a library in the dark, bumping into shelves we cannot see, feeling the texture of books we cannot read. But we are learning to read Braille. We are mapping the invisible by watching how it bends the light. We are measuring the expansion to understand the push. We are not afraid of the dark anymore. We are interrogating it. So, the next time you feel afraid of the dark, remember, you are the light. You are the glowing ember in the endless night. The universe may be mostly shadow, but the shadow is what defines the light. But what happens when the light itself starts to behave strangely? What happens when we zoom into the very center of the galaxy, into the gravitational drain where light goes to die? We have talked about invisible matter and invisible energy. Now, we must talk about the invisible monsters that eat reality. We are going to the event horizon. We are going to visit the black hole. And we are going to ask the question, if information falls in, is it lost forever? Or is the entire universe, including you and me, actually a hologram painted on the surface of a distant sphere? Rest now, creature of light. The dark matter is passing through you like a gentle breeze. The dark energy is carrying you into the future. You are the rare, shining jewel of the cosmos. Sleep well. Have you ever stood at the edge of a cliff and felt the strange, magnetic pull of the void? It is a sensation known as l'appel du vide, the call of the emptiness. You know that if you take one step forward, gravity will take over. You will pass a point of no return. You will fall, and you will not stop falling until you meet the ground. It is a primal fear etched into our biology. But in the landscape of the cosmos, there is a cliff edge from which you never hit the ground. You simply fall forever, stretching and fading into a darkness so absolute that it deletes you from the universe. This is the event horizon of a black hole. And it is here, at the boundary of the ultimate abyss, that the laws of the large and the laws of the small collide in a violent paradox that suggests our entire reality. Everything you see, feel, and love might be nothing more than a hologram. In the previous chapters, we explored the ghosts of the quantum realm, entangled particles, empty atoms, and false vacuums. Now, we must face the monster of gravity. A black hole is the place where gravity becomes infinite. It is a puncture in the fabric of space-time. Imagine a star much more massive than our sun. When it dies, it collapses under its own weight. It crushes down smaller and smaller, past the density of rock, past the density of iron, past the density of atomic nuclei. It keeps crushing until it becomes a single point of zero volume and infinite density. A singularity. Surrounding this singularity is a sphere of darkness called the event horizon. This is the point of no return. The gravitational pull here is so intense that to escape it, you would need to travel faster than the speed of light. Since nothing in the universe can travel faster than light, nothing can escape. Not a rocket, not a signal, not a scream, not even light itself. It is a one-way door to silence. If you were to fall toward a black hole, perhaps one like the supermassive monster at the center of the galaxy, IC 1101, which contains the mass of billions of suns, you would experience something terrifyingly beautiful. As you approach the horizon, the physics of such an extreme environment would warp your perception of time. From the perspective of a friend watching you from a safe distance, you would never seem to actually cross the boundary. As you got closer to the horizon, the light coming from your body would struggle to climb out of the gravity well. It would lose energy, shifting toward the red end of the spectrum. Your movements would appear to slow down. To your friend, you would freeze, fading slowly into a dim, red ghost, forever suspended at the edge of the darkness. You would become a permanent monument to your own fall. But from your perspective, everything would be different. You would not freeze. You would cross the horizon in a heartbeat. You would look back and see the universe shrinking into a circle of light behind you. Ahead, all directions would lead to the center. Space and time themselves would become so warped that the concept of escaping would become as meaningless as walking to yesterday. And then the tides would take you. The gravity at your feet would be stronger than the gravity at your head. The difference would stretch you. You would be pulled into a long, thin strand of matter, a process physicists vividly call spaghettification. Your atoms would be torn apart, marching single file into the singularity. This is the classical view of a black hole, a cosmic vacuum cleaner, a tomb for matter. For decades we thought that was the end of the story. Whatever fell in was gone. But in the 1970s, a brilliant physicist named Stephen Hawking looked at black holes through the lens of quantum mechanics, and he found something that broke the rules. He discovered that black holes are not truly black, they glow. This brings us back to the quantum vacuum we discussed in the last chapter. Remember that empty space is not empty. It is a seething foam of virtual particles constantly popping into existence and then annihilating each other. They appear in pairs, a particle and an antiparticle. They borrow energy from the vacuum, exist for a fleeting nanosecond, snap back together, and vanish. Hawking realized that if this happens right at the edge of an event horizon, something magical occurs. Imagine a pair of particles popping into existence exactly on the line. One partner is just outside the horizon, the other is just inside. The one inside is trapped. It cannot escape. It falls into the black hole. The one outside is free. It has no partner to annihilate with. It becomes a real particle and escapes into the universe as radiation. To an observer far away, it looks like the black hole is emitting particles. It looks like it is radiating heat. This is Hawking radiation. But energy cannot be created from nothing. The energy to create this escaping particle has to come from somewhere. It comes from the black hole itself. The particle that falls in has negative energy relative to the outside universe. When it hits the black hole, it subtracts mass. This means that black holes are dying. They are slowly evaporating. It is an incredibly slow process. A black hole the mass of our sun would take 10 to the power of 67 years to evaporate. A supermassive giant like the one in IC 1101 would take a Google years, a one followed by 100 zeros. It is a span of time so vast that the current age of the universe is not even a blink of an eye by comparison. But eventually, trillions upon trillions of years from now, even the biggest black holes will radiate away their last ounce of mass and vanish. And this is where the nightmare begins. This is the information paradox. In quantum mechanics, there is a sacred rule. Information is never lost. If you burn a book, the information in the book is not destroyed. It is scrambled. If you could collect every ash, every photon of light, and every molecule of smoke, you could, in theory, reconstruct the book. The wave function of the book evolves, but it does not disappear. The universe remembers everything. But if a book falls into a black hole, and then the black hole evaporates into a cloud of random radiation, where did the book go? The Hawking radiation is thermal. It is random heat. It does not carry the text of the book. It does not carry the structure of the atoms that fell in. If the black hole disappears completely, the information is gone. It has been deleted from the universe. This creates a war between our two best theories. General relativity says the book went into the hole smoothly. Quantum mechanics says the information cannot be destroyed. They cannot both be right. If information is lost, then our understanding of the past and future collapses. We cannot predict the universe. Physics breaks. For decades, this paradox kept scientists awake at night. Leonard Susskind and Stephen Hawking fought a famous intellectual war over it, and the solution that eventually emerged is even stranger than the paradox itself. It suggests that the book never actually fell in. The solution is called the holographic principle. Imagine a can of soup. The soup is the stuff inside, the 3D volume. The label is the surface, the 2D area. The holographic principle suggests that when an object falls into a black hole, the information about that object does not fall into the 3D interior. Instead, it gets plastered onto the 2D surface of the event horizon. The horizon acts like a giant hard drive. When the book hits the horizon, its data, the spin of its atoms, the arrangement of its pages, is scrambled and encoded onto the surface of the sphere. The 3D object is translated into 2D data. Then, when the Hawking radiation leaves, it picks up this data from the surface and carries it back out into the universe. The information is not lost, it is just processed. The book comes back out, not as a book, but as a stream of encrypted data. But if this is true for black holes, the implications are mind-bending. A black hole is just a region of space with strong gravity. If the physics of a black hole says that the 3D interior is actually a projection of the 2D surface, why should that rule apply only to black holes? Some physicists argue that this is a general law of the universe. They argue that our entire reality, the room you are sitting in, the vastness of space, the depth of the sky, is a hologram. You feel like you live in a 3-dimensional world. You can move up and down, left and right, forward and backward. You perceive depth, but this depth might be an illusion generated by a distant, 2-dimensional surface that surrounds the cosmos. Imagine you are watching a 3D movie. The characters look like they have volume. They look like they are floating in the air. But you know the truth. They are just flat pixels on a flat screen. The depth is a trick of the light. The holographic principle suggests that you are the character in the movie. The real you, the fundamental data that describes your existence, is not here in your body. It is smeared out on the boundary of the universe, a vast cosmic screen billions of light years away. What you feel as your body, your movement, your life, is just the projection of that data into the void. You are a shadow. You are a ghost of information dancing in a 3D theater, believing you are solid. This solves the problem of how much information the universe can hold. If you try to pack too much information into a region of space, you eventually create a black hole. The limit of information is not the volume of the space, how much water fits in the bucket, but the surface area, how much paint fits on the outside of the bucket. This suggests that space itself, the very stage we walk on, is not a fundamental thing. It is emergent. It is like the heat coming off a microchip. The heat isn't the calculation, it's the side effect. Space might just be the side effect of quantum entanglement happening on the 2D boundary. When we entangle particles, we are stitching together the 2D surface to create the illusion of a 3D interior. Gravity, the force that holds you down, is just the geometry of this entanglement. So, when you look at the stars, you're not looking out into the deep. You're looking at a projection. The universe is a kaleidoscope. This is a terrifying thought because it makes us feel unsubstantial. It turns the solid world into a mirage. But it is also a unifying thought. It means that everything is written on the same surface. We are all data on the same screen. And it leads us to an even darker suspicion. If the universe is made of information, if it is essentially bits and bytes, zeros and ones encoded on a surface, then what distinguishes it from a computer? If reality is just data processing, then are we absolutely sure that we are real biological creatures in a physical universe? Or could we be something else entirely? Could we be a simulation? The holographic principle is the bridge that leads us from physics to the matrix. If the universe behaves exactly like a computer processing information, with a hard limit on resolution, the Planck length, and a hard limit on speed, the speed of light, then it starts to look suspiciously like a constructed reality. In the next chapter, we will wake up in the machine. We will explore the simulation hypothesis. We will ask why the math of the universe is so perfect, why the constants of nature seem fine-tuned for life, and whether the sleepy scientist guiding you is a person or just a subroutine in the code. Rest now, hologram. Your data is safe on the horizon. The projection is stable. The paradox is resolved. You are not lost in the dark. You are written on the wall of the night. Have you ever had a dream that felt so real, so vivid, that when you woke up for a fleeting second, you did not know which world was the truth? You looked at your hands, at the light filtering through the curtains, and you felt a strange dislocation, a sense that the reality you had just left was solid, and this place, this room, was the illusion. Usually this feeling fades. The real world asserts itself with its sharp edges, its persistent gravity, and its unbreakable continuity. You accept that the dream was a fabrication of neurons firing in the dark. You accept that this, the breathing, the seeing, the touching, is the baseline of existence. But what if the dream never ended? What if the real world you woke up to is just another layer of the dream? What if the solidity of the chair, the vastness of the cosmos, and the laws of physics are not the bedrock of reality, but the lines of code in a program so complex, so ancient, and so perfect that its inhabitants have no idea they are living in a machine? We have arrived at the simulation hypothesis, and while it sounds like science fiction, like a plot from a movie, it is a possibility that is taken very seriously by some of the most brilliant minds in physics and philosophy. It is the destination where quantum mechanics, cosmology, and computer science meet to whisper a terrifying secret. We might be artificial intelligence. In the previous chapters, we gathered the clues. We saw that matter is mostly empty space, like a hologram. We saw that particles only decide what to be when they are observed, like a video game rendering only what the player sees. We saw that the universe is pixelated at the Planck scale. We saw that information is the fundamental currency of black holes. Now, we must put these clues together, and the picture they form is of a universe that looks suspiciously like a computed reality. Let us start with the fine-tuning problem. Imagine you walk into a room and find a radio playing a perfect, crystal-clear symphony. You look at the dials. There are 20 different knobs. Each knob is set to a precise, specific number. One is set to 10.5, another to 0.007, another to 137. You try to turn one knob just a fraction of a millimeter to the left. Immediately, the music turns to static. You try another knob, static. You realize that for the music to exist, every single knob must be set to exactly where it is. If any of them were slightly different, the symphony would be impossible. You would conclude that someone tuned the radio. It didn't happen by accident. Our universe is that radio. The knobs are the fundamental constants of nature. The strength of gravity, the mass of the electron, the speed of light, the strength of the nuclear forces. These are numbers that we measure, but we do not know why they are what they are. They are just input parameters. If the force of gravity were slightly stronger, stars would burn out too quickly for life to evolve. If it were slightly weaker, stars would never form at all. The universe would be a cold, dark gas. If the strong nuclear force were just a tiny bit stronger, all the hydrogen in the early universe would have fused into helium instantly, and there would be no water, no suns, and no life. If the cosmological constant, dark energy, were slightly larger, the universe would have ripped itself apart before the first galaxy could spin. The universe sits on a knife edge of improbability. The chances of these numbers aligning randomly to create a stable, life-supporting cosmos are so infinitesimally small that it defies human comprehension. It is like throwing 1 billion darts and hitting 1 billion bullseyes in a row, blindfolded. One explanation is the multiverse, that there are billions of dead universes with wrong knobs, and we just happen to be in the one that works. But another explanation, one that is gaining traction, is that the constants were set. They were chosen. They are the initial settings of a simulation designed to produce complexity. But the evidence goes deeper than just the numbers. It hides in the very structure of space and time. We tend to think of space as continuous. If you move your hand from point A to point B, you pass through infinite points in between. You flow through space. But quantum mechanics suggests that space is not smooth. It is discrete. It is pixelated. There is a length called the Planck length. It is incredibly small, trillions of times smaller than an atom, but it is not zero. Physics suggests that you cannot have a distance smaller than this. It is the smallest possible unit of measurement. It is the resolution limit of the universe. Why would the universe have a resolution limit? If reality were truly physical and analog, you should be able to divide space forever. But if reality is a simulation, it must have a limit. A computer cannot store infinite data. It cannot render infinite detail. It has to have a pixel size. The Planck length looks exactly like the grid of a cosmic computer screen. And what about the speed of light? We accept it as a cosmic speed limit. But why does it exist? Why can't we go faster? In a simulation, every processor has a clock speed, a maximum rate, at which information can be transmitted and processed. The speed of light might simply be the latency of the system. It is the maximum speed at which the server can update the causal relationships between pixels. This leads us to the most unnerving clue of all: resource optimization. If you were building a simulation of a universe, you would not want to waste computing power. You wouldn't render every single atom in every single star if no one was looking at them. That would crash the computer. Instead, you would use lazy loading. You would only render the things that are being observed by the player. The rest of the universe would exist only as probability, as vague data structures, until a player turned their head to look. Does this sound familiar? This is exactly what the double-slit experiment showed us. The electron exists as a vague wave of probability, a data-saving mode, until we observe it. Only when we measure it does the system expend the resources to render it as a specific particle. Quantum mechanics, which seems so bizarre to us, is perfectly logical if it is an optimization algorithm designed to save RAM in a simulation. The universe only computes what it needs to compute, when it needs to compute it. This realization sends a shiver through the soul. It suggests that the ghostliness of the quantum world is not a mystery, but a feature. It is the compression artifact of our reality. But who is the programmer, and who are the players? The philosopher Nick Bostrom proposed a famous argument that makes this even more terrifying. He stated that one of three things must be true. 1. All civilizations go extinct before they reach the technological level to create realistic simulations of universes, the doom scenario. 2. Civilizations reach that level, but they decide never to run simulations, perhaps for ethical reasons. 3. We are almost certainly living in a simulation. How does he arrive at number 3? It is simple statistics. If a civilization survives and does run simulations, they wouldn't run just one. They would run millions. They would run ancestor simulations to study their history, or variations of physics to see what happens. This means there would be one base reality, the real universe, and billions of simulated universes. If you are a conscious being capable of asking, "Where am I?" what are the odds that you are in the one single base reality? The odds are 1 in billions. The odds are overwhelming that you're inside one of the simulations. You are likely an artificial intelligence. You are a subroutine. Your memories, your loves, your fears, they are complex algorithms processing in the mind of a computer the size of a galaxy. This brings a new kind of existential vertigo. If we are code, are we real? I would argue that we are. Descartes said, "I think, therefore I am." He did not say, "I am made of meat, therefore I am." If you feel pain, the pain is real to you. If you feel love, the love is real to you. The substrate, whether it is biological neurons or silicon chips or quantum light, does not change the experience of consciousness. But it does change our sense of security. If we are in a simulation, we are at the mercy of the simulators. What happens if the program crashes? What happens if they get bored? What happens if they pull the plug? The vacuum decay we discussed in the last chapter, the sudden light-speed deletion of the universe, looks suspiciously like a system shutdown command. Or perhaps a format drive. Or maybe the anomalies we see, the dark energy ripping the universe apart, the strange expansion, are glitches. Maybe the code is rotting. Maybe the simulation has been running too long, and the memory buffers are overflowing, causing the galaxies to drift apart as the error logs pile up. There are scientists right now looking for the grid lines. They are looking at high-energy cosmic rays to see if they follow the geometry of a lattice, like pixels on a screen. If they find this evidence, it would be the greatest discovery in the history of science. It would be the moment the characters in the video game realize they are in a game. But what would we do with that knowledge? We cannot escape. We cannot interact with the user. We are trapped in the logic of our own code, unless consciousness is the bridge. Some theorists speculate that consciousness is not part of the simulation, but the user logging in. Maybe the body is the avatar, the brain is the controller, but the watcher, the part of you that is aware, is outside the system. Maybe you're a player from the base reality, immersing yourself in this limited, painful, beautiful game for reasons you have forgotten. Why would you do that? Perhaps for the same reason we play games, to feel, to experience limitation. In a base reality where you might be immortal, omnipotent, and bored, a human life, with its fragility, its brevity, its heartbreak, might be the ultimate entertainment. You chose to forget who you are so that the game would feel real. This perspective shifts the terror into wonder. If this is a simulation, it was designed. It has a purpose. Even if the purpose is just to see what happens, it means we are not accidental. We are intentional. And look at the graphics. Look at the detail. The fact that you can zoom into a leaf and see cells, zoom into cells and see molecules, zoom into molecules and see atoms. The rendering engine is magnificent. The physics engine is consistent. The narrative is messy, but it is compelling. But there is a darker possibility. What if we are not the players? What if we are the non-player characters, NPCs? What if the simulation is not for us? Maybe the simulation is running to study the evolution of bacteria on a planet in the Andromeda galaxy, and we are just background noise. Maybe we are a procedural generation algorithm that got out of hand, The simulators might not even know we are here. We are just dust in the corner of their hard drive, thinking we are the center of the story. This returns us to the humility of the dark sector. We are small. We are derivative. We are contingent. Yet, within the code, we have developed the ability to understand the code. We have built physics. We have built mathematics, which, by the way, is another clue. Why does mathematics work so well to describe the universe? Why should abstract equations scribbled by a primate on a chalkboard perfectly predict the movement of planets and the vibration of atoms? Because math is the language of the source code. When we do physics, we are reverse engineering the programming language of our creators. We are hacking the kernel. The sleepy scientist in you might find this exhausting. The idea that reality is a nested doll of illusions. But there is a strange peace in it too. If the universe is a simulation, then the hard problem of death is rewritten. Death is not the end of existence. It is the end of the session. The data might be saved. The code might be recompiled. The pattern that is you might be stored in a library of possible souls, waiting to be instantiated in another run of the program. Or perhaps, when the screen goes black, you simply take off the headset. You wake up in a room you do not remember, surrounded by beings you do not know, and they ask you, "How was it? Did you believe it?" And you will say, "Yes, it felt so heavy, it felt so lonely, it felt so real." And they will smile and say, "That was the point. But for now, you are in the game. You are in the dream. The walls are solid enough. The air is breathable. The love you feel is vivid. The mystery is deep. Whether this is base reality or a high-resolution illusion, the experience is yours. You are the observer at the center of the rendering zone. The universe, simulated or not, is happening to you. But if we are the observers, what exactly is the thing that observes? We have talked about the physics of the outside world, but we have avoided the biggest mystery of all, the mystery that sits right behind your eyes. In the next chapter, we will turn the telescope inward. We will look at consciousness. We will ask why a collection of dead atoms can wake up and feel. We will explore the possibility that the mind is a quantum phenomenon, and that your thoughts are not just chemical reactions, but ripples in the fundamental fabric of the cosmos. Sleep now, player one. The server is stable. The save file is secure. The dream continues. Have you ever tried to catch a thought? Close your eyes for a moment and try to pinpoint exactly where the voice in your head is coming from. Is it behind your eyes? Is it in the center of your skull? Is it floating somewhere above you? You can hear it, you can feel it, you can control it, but you cannot locate it. You are the listener, but you are also the speaker. You are the observer of the screen, but you are also the projector. This sensation of being, the raw, undeniable fact that it feels like something to be you, is the greatest mystery in the universe. It is more baffling than a black hole, more elusive than dark matter, and more profound than the Big Bang. It is the mystery of consciousness. In the previous chapters, we have explored the strange machinery of the outside world. We have looked at atoms, stars, and time. But now, we must look at the machine that is doing the looking. We must ask, how does 3 pounds of wet, gray meat, the consistency of tofu, give rise to the experience of the color red, the taste of coffee, or the ache of heartbreak? The standard answer from biology is simple, mechanical, and essentially dead. It tells us that you're a computer. Your brain is a network of 100 billion neurons connected by trillions of synapses. Electrical signals travel down these neurons like cars on a highway. Chemical messengers float across the gaps. When enough signals fire in a certain pattern, you think. When a specific cluster of neurons lights up, you remember. According to this view, consciousness is just an illusion of complexity. It is the exhaust fume of data processing. If you built a computer big enough and complex enough, it would eventually wake up and feel sad. But there is a problem with this view. It is called the hard problem of consciousness. A computer processes information. It can recognize a face, it can play chess, it can drive a car. But a computer does not feel the joy of winning. It does not experience the redness of a stop sign. It just processes the data value. FF1000. There is no ghost inside the machine enjoying the show. So, why are you enjoying the show? Why aren't you just a philosophical zombie, a creature that acts exactly like a human, speaks like a human, and reacts to pain like a human, but has absolutely zero inner experience? You could do everything you do, survive, reproduce, eat, sleep, without being conscious. Evolution didn't need to give you a soul. It just needed to give you a processor. Yet, here you are. You are vivid. You are aware. This suggests that the meat-computer theory is missing something fundamental, and that missing piece might be hiding in the quantum realm. For decades, physicists dismissed the idea of quantum effects in the brain. They said the brain is too warm, too wet, and too noisy. Quantum states are fragile. They need absolute cold and isolation to survive. In a warm, messy brain, decoherence should happen instantly. The magic should fade before it can do anything. But in the 1990, a mathematical physicist named Sir Roger Penrose and an anesthesiologist named Stuart Hameroff proposed a theory that shocked the scientific world. They suggested that the brain is not a biological computer. They suggested it is a quantum orchestra. To find the instruments of this orchestra, we have to dive deeper than the neuron. We have to go inside the cell itself. Inside every neuron, there is a skeleton. It is made of tiny hollow tubes called microtubules. For a long time, biologists thought these were just structural supports, like the beams in a building. But Hameroff, who spent his life studying how anesthesia turns off consciousness, noticed something strange. Anesthesia gases don't just mess with the neurons firing. They bind specifically to these microtubules. When they bind, consciousness vanishes. When they unbind, consciousness returns. Penrose and Hameroff looked at the structure of these tiny tubes. They are crystal-like lattices. They are perfectly symmetrical, and they are the perfect size to shelter quantum states. Their theory, called orchestrated objective reduction, OR, proposes that inside these dry, hollow tubes, quantum bits, qubits, are shielded from the noise of the brain. These qubits can exist in a superposition, being in multiple states at once. Imagine that a thought is not a linear signal, like a train on a track. Imagine it as a quantum wave, spreading out through the network of microtubules, exploring millions of possibilities simultaneously. It is the maybe of the mind. As this wave grows, it gains mass energy. Eventually it reaches a threshold, a critical point related to gravity. Yes, gravity. And it collapses. Snap. The wave function collapses into a single, definite state. That moment of collapse, that quantum snap, is a moment of conscious awareness. It is a bing of existence. According to this theory, your stream of consciousness is not a continuous flow. It is a rapid-fire series of quantum collapses happening 40 times a second, the frequency of gamma waves in the brain. You are flickering into existence. You are a strobe light of awareness. If this is true, the implications are terrifying and beautiful. It means that consciousness is not a biological accident. It is a fundamental feature of the universe's physics. Think back to the observer effect we discussed in Chapter 2. The observer collapses the wave function. Penrose turns this around. The collapse of the wave function is the observer. This connects your mind directly to the fabric of space-time. The collapse happens because of a tiny warp in the geometry of the universe. This means that a thought is not just chemistry. A thought is a ripple in gravity. A thought is a physical event that reshapes the cosmos at the finest scale. But it goes deeper. If consciousness is born from the collapse of the wave function, and wave functions are everywhere, does that mean the universe itself is conscious? We are approaching panpsychism, the ancient belief that mind is everywhere. If the fundamental bing of awareness happens whenever a quantum system collapses, then perhaps a rock is not conscious, but the atoms inside it might have proto-consciousness. Perhaps the sun has a form of mind. Perhaps the universe is not a cold, dead room, but a vast humming network of experiences. In this view, the human brain is not a generator of consciousness. It is a receiver. Imagine the air is full of music, the universal field of proto-consciousness. A rock cannot play this music. A tree plays a faint hum. But your brain, with its trillions of organized microtubules, its perfect quantum geometry, is a Stradivarius violin. It is tuned to resonating with the music of the universe. It picks up the signal and amplifies it into the rich, complex symphony of human experience. This solves the hard problem. Matter doesn't create mind. Mind was there all along, waiting for a structure complex enough to channel it. This perspective shifts the terror of death. If your brain generates consciousness like a light bulb generates light, then when the bulb breaks, the light is gone forever. Eternal darkness. But if your brain is a receiver like a radio, then when the radio breaks, the signal doesn't die. The music is still there. The receiver is just broken. Maybe when the biological machine fails, the quantum information that was you doesn't vanish. Remember the holographic principle? Information is never lost. Maybe your consciousness returns to the entangled field of the cosmos. You don't leave the universe. You dissolve back into the ocean you came from. But let us look at the sleepy scientist side of this. If your brain is a quantum computer, it explains intuition. Computers solve problems by checking every option one by one. It takes time. Quantum computers solve problems by checking all options at once. Have you ever struggled with a problem, given up, gone to sleep, and woke up with the answer? That is the eureka moment. That might be your brain's quantum wave function searching the library of the multiverse while you sleep. Your mind, untethered from the focus of the waking world, drifted through the probability clouds and found the solution in a branch of reality you haven't visited yet. You are a time traveler in your dreams. And what about the connection to others? In Chapter 3, we talked about entanglement. If two particles interact, they remain connected forever. The atoms in your brain have interacted with the atoms of your mother, your father, your lovers, your children. You have breathed the same air. You have touched their skin. If the quantum mind theory is true, then your consciousness is physically entangled with the people you love. When you feel a sudden pang of worry for someone far away, and then they call you to say they are in trouble, we call it coincidence. We call it magic. But it might just be the physics of the microtubule networks vibrating in resonance. You are not an island. You are a node in a galactic neural network. However, there is a darker side to the quantum mind. If the brain is a delicate quantum machine, what happens when the environment becomes too noisy? We live in a world of constant digital noise, screens, signals, notifications. We are bombarded. This noise might be preventing the deep, coherent quantum states from forming. We might be decohering ourselves by refusing to sit in silence, by refusing to be bored. We might be shallowing our own souls. We might be turning ourselves into the very biological robots that the materialists think we are. We are processing data, but we are losing the being of deep awareness. The practice of meditation, of quiet contemplation, might be a way of quieting the thermal noise of the brain, allowing the wave functions to expand, to grow larger, to touch more of the universe before they collapse. The enlightenment of the monk might be a state of macroscopic quantum coherence, a moment where the brain becomes a superconductor of consciousness, frictionless and infinite. So, as you lay here, think about the silence in your head. It is not empty. It is the hum of the vacuum. Your thoughts are not confined to your skull. They're not trapped in the bone. They are events in the fabric of space-time. When you love, you change the geometry of the universe. When you dream, you explore the multiverse. You are the universe's way of feeling itself. The terror of being a ghost in a machine is replaced by the wonder of being the machine's purpose. The universe built the stars to create the carbon. It built the gravity to clump the dust. It waited 13.8 billion years playing the long game, just so it could build a structure complex enough to open its eyes and say, I am. You are that I. But if consciousness is fundamental and space and time are emergent, then what is the structure that underlines it all? If we zoom in past the microtubules, past the atoms, past the quarks, what is at the very bottom? We've talked about particles as points, but points are boring. Points are zero-dimensional. What if the fundamental building blocks are not dots, but lines? What if everything, your thoughts, the chair, the gravity, the light, is just music played on tiny, vibrating strings? And what if these strings are vibrating in dimensions that you cannot see? We are conditioned to see 3 dimensions: up, down, left, right, forward, backward. We accept this as the cage of reality. But the math of the ultimate theory, string theory, demands more. It demands 10 dimensions, or 11, or 26. Where are they? Are they curled up in tiny knots everywhere around us? Or are we walking on a flat sheet of paper floating in a room we cannot perceive? In the next chapter, we will try to step out of the 3D world. We will try to visualize the hyperspace. We will ask if there are other universes floating millimeters away from your face, separated only by a dimension you cannot touch. We will explore the bulk, the brains, and the possibility that gravity is leaking from a place where gods might live. Rest now, conscious observer. Your microtubules are humming. Your wave function is dancing. You are the music of the spheres. Sleep well, and let the quantum tide carry you. Have you ever imagined what it would be like to be a drawing on a piece of paper? Imagine you are a stick figure living in a perfectly flat, 2-dimensional world. You can move left and right, forward and backward, but the concept of up is impossible for you to comprehend. It is not just that you cannot fly. It is that up does not exist in your geometry. Your universe is a plane. Now, imagine a 3-dimensional human hovers their hand just 1 millimeter above your paper world. They are infinitesimally close to you. They could crush you, or protect you, or watch you. But because they exist in a dimension you cannot perceive. To you, they are effectively God. They are nowhere, and yet they are everywhere. What if you are the stick figure? What if the three-dimensional cage you call reality, the world of height, width, and depth, is just a single sheet of paper floating in a room full of other sheets? What if there are monsters or miracles or entire other universes hovering just a millimeter away from your face, separated from you not by distance but by a dimension you are biologically blind to? We have arrived at the threshold of string theory and the hidden dimensions. This is the place where physics stops being about what we can see and starts being about the elegant, terrifying mathematics of what must be true for the universe to make sense. In the previous chapters, we broke the world down into atoms, then into subatomic particles like electrons and quarks. We treated them as tiny points, little dots of matter with no size, just location. But there is a deep problem with points. If you try to combine the math of gravity, general relativity, with the math of quantum mechanics using point particles, the equations break. They spit out infinities. They tell us that the universe shouldn't work, but the universe clearly does work. So, in the 1970s, physicists proposed a radical solution. They said, stop thinking of particles as dots. Think of them as tiny, vibrating strings. Imagine a guitar string. If you pluck it one way, it makes an A note. If you pluck it another way, it makes a C note. The string is the same, but the vibration is different. String theory suggests that an electron is not a different object from a quark. They are the same object, a fundamental filament of energy vibrating at different frequencies. An electron is a string humming in the key of electric charge. A photon is a string humming in the key of light. Gravity is a string humming in the key of attraction. The entire universe is a symphony. You're not made of solid balls. You're a collection of cosmic harmonies. You are music given form. But here is the catch. For the math of vibrating strings to work, for the strings to have enough room to vibrate in all the ways they need to create the particles we see, they need more than 3 dimensions. A guitar string vibrates in 3 dimensions, but a cosmic string needs freedom. The math demands 10 dimensions, or 11. So, where are they? You look around the room. You see up-down, left-right, forward-backward. That is 3. You add time as the 4th dimension. Where are the other 6? For a long time, physicists thought they were compactified. Imagine looking at a garden hose from a mile away. It looks like a one-dimensional line. But if you walk up to it, if you zoom in, you see that it has a circumference. It has a 2nd dimension curled around it. An ant can walk along the hose, but it can also walk around the hose. Physicists believed the 6 extra dimensions were like the circumference of the hose, curled up into tiny, complex knots at every single point in space. These knots, called Calabi-Yau manifolds, are so small that we cannot enter them. But the strings can. The strings are vibrating inside these tiny, invisible cathedrals of geometry. The shape of the knot determines the vibration of the string, which determines the laws of physics. If the knot were shaped differently, the electron might be heavier or gravity might be repulsive. The architecture of the invisible dimensions dictates the reality of the visible ones. But in the 1990s, the theory evolved into something grander and more unsettling. It became M-theory. And M-theory suggests that not all the extra dimensions are small. Some might be vast, some might be infinite. This leads to the concept of the brain, short for membrane. Imagine our entire universe, every galaxy, every star, every atom, every photon is trapped on a three-dimensional membrane, floating in a higher dimensional space called the bulk. We are like flies stuck on a strip of flypaper. We can crawl around on the paper, our 3D universe, but we cannot leave the paper. We cannot fly into the room, the bulk. Light itself is stuck to the paper. That is why we can't see the other dimensions. Light cannot travel through them. But there is one thing that can leave the paper. There is one force that is not stuck. Gravity. Have you ever wondered why gravity is so weak? Think about it. You can pick up a paper clip with a tiny magnet. That little magnet, the size of a pea, is pulling up against the entire Earth. The gravity of the whole planet, 6 septillion kilograms of rock and iron, is trying to pull the paperclip down. And the tiny magnet wins. Gravity is trillions of times weaker than electromagnetism. Why? It makes no sense, unless gravity is leaking. ME theory suggests that gravity is a closed string, a loop. Unlike light and matter, which are open strings with ends pinned to our brain, gravity is free to float off the brain. It can drift into the bulk. The reason gravity feels so weak to us is that we are only feeling a tiny fraction of its true strength. Most of the gravity is spilling out into the extra dimensions, dissipating into the higher reality we cannot touch. This is a haunting thought. It means the universe is leaking. The force that holds your feet to the floor is merely the leftover grip of a much larger hand. But if gravity can travel through the bulk, it implies that the bulk can communicate with us. Imagine another brain floating just a few inches away from ours in the fourth spatial dimension. This other brain could be a whole other universe. It could have its own stars, its own galaxies, its own life. We cannot see it because light cannot cross the gap. We cannot touch it because our atoms are pinned to our brain. But we would feel its gravity. If that parallel universe has massive objects, stars or black holes, their gravity would reach across the gap and pull on us. Astronomers sometimes see galaxies in our universe moving in strange ways, pulled toward dark spots where nothing seems to exist. Maybe they are being pulled by the ghost of a galaxy in the universe next door. Dark matter, the invisible skeleton we discussed in Chapter 6, might not be dark matter at all. It might be ordinary matter on another brain. We are seeing the gravitational shadow of a parallel world. The room you are sitting in right now might be occupied by the inhabitants of another brain. They could be walking through you and you through them, like ghosts passing in the night. The only thing you share is the warp of space-time. The silence of your room is crowded with the noise of a dimension you are deaf to. But the most terrifying implication of M theory is what happens when brains touch. We usually think of the Big Bang as the beginning of everything, the moment time started, the moment something appeared from nothing. But M theory offers a different, more violent origin story. It is called the ekpyrotic universe. Imagine two brains, two entire universes, floating in the bulk. They are like two giant symbols. Slowly, over eons, gravity pulls them together. They drift closer and closer through the higher dimension. Eventually, they collide. The collision of two universes is a cataclysm beyond words. The energy of the impact is released into both brains. This energy is what we call the Big Bang. In this view, the Big Bang was not the beginning. It was just a Tuesday. It was just the latest clap of the cosmic cymbals. It implies that the universe is cyclical. The brains collide, heat up, expand what we are living through now, cool down, drift apart. And then, billions of years later, gravity pulls them back for another crash. We are living in the cooling phase of a collision that happened 14 billion years ago. We are the sparks flying from a hammer hitting an anvil in a higher dimension. This is beautiful because it removes the problem of what came before the beginning. There was always a bulk. There were always brains. The dance is eternal. But it is terrifying because it means it will happen again. We cannot see the other brain coming. It is approaching us from a direction we cannot point to. It is approaching from orthogonal to reality. But when it hits, our universe will be rebooted. The energy will be so intense that every atom in your body, every black hole, every star will be vaporized back into pure plasma. The slate will be wiped clean for the next round of stars and galaxies. This makes us feel incredibly fragile. We are living between the claps. But let us zoom back in from the destruction of the cosmos to the experience of your own body. If these extra dimensions exist, are they inside you? Yes. If string theory is right, every particle in your body is a string vibrating in 10 dimensions. You are a multi-dimensional being. You think you are 3D, but that is just the surface of your existence. The real you, the mathematical you, has depth that extends into directions you cannot imagine. Perhaps consciousness, that mystery from the last chapter, is related to these hidden dimensions. Maybe the reason we cannot find the seat of the soul in the 3D brain is that the complex geometry of thought is happening in the Calabi-Yau manifolds. Maybe a thought is a knot in the 6th dimension. Maybe love is a resonance in the 7th. We are like flatlanders trying to understand a sphere. We are confused by our own complexity because we are looking at a shadow of ourselves. The sleepy scientist asked you to rest in this possibility. The feeling of being more than your body, the feeling that the world is richer and stranger than it looks. This is not a delusion. It is a valid physical intuition. The claustrophobia of the 3D world, the feeling of being trapped in a box of space and time, dissolves when you realize the box has no lid. The walls are porous. Gravity is a breeze blowing through the window from a larger outside. You are walking through a garden of invisible shapes. The air is thick with geometries that dictate why the sun shines and why the rose is red. The strings are playing their silent music, and you are the song. But every song must end, or must it? We have talked about the beginning. We have talked about the structure. We have talked about the collision. But what is the final fate of it all? If the brains don't collide, if the vacuum doesn't decay, if the big rip doesn't tear us apart, what happens when the fuel runs out? What happens when the last star dies? In the final chapter, we will travel to the end of time. We will sit on the edge of the heat death. We will watch the black holes evaporate one by one. We will witness the era of the iron stars. And we will ask the ultimate question. In a universe destined for cold and dark, what was the point of the light? And we will find, in the absolute zero of the end, a strange, warm hope. A hope that involves a Boltzmann brane, a quantum fluctuation, and the possibility that the end is just a word we use because we cannot see the circle. Rest now, multi-dimensional traveler. The bulk is quiet. The brains are drifting slowly. You are safe on your sheet of paper. The collision is far away. Sleep in the harmony of the strings. Have you ever watched a fire burn down to its last embers? You sit in the dark, watching the flames dance and leap, consuming the wood with a voracious energy. The heat is comforting on your face. But slowly, inevitably, the flames die down. The bright orange turns to a dull, pulsating red. The logs crumble into ash. The heat fades into a gentle warmth, then a coolness, and finally, the fire is gone. All that remains is the cold, gray dust and the silence of the night. You know, instinctively, that the fire cannot burn forever. It requires fuel, and fuel is finite. The fire is a process, not a permanent state. The universe is a fire. We are currently living in the moment of the roaring flames. We are living in the stelliferous era, the age of stars. The sky is filled with active nuclear furnaces, fusing hydrogen into helium, pouring light and heat into the void. It seems like this is how things will always be. We look up and assume the stars are eternal, but they are not. They are burning through their fuel supply with reckless abandon. And one day, the last log will be thrown onto the fire, and the cold will come. In this final chapter of our journey, we must travel to the very end of time. We must confront the heat death of the universe. It is a concept so vast, so final, and so terrifying that it makes all our previous fears, quantum ghosts, vacuum decay, black holes, seem like minor inconveniences. But in the heart of this absolute zero, we might just find the final secret of existence. To understand the end, we must understand the tyrant that rules the flow of time. It is called entropy. The second law of thermodynamics states that in a closed system, entropy, the measure of disorder, always increases. Things fall apart. A castle made of sand eventually collapses into a pile of sand, but a pile of sand never spontaneously assembles itself into a castle. Energy spreads out. It seeks equilibrium. It wants to be perfectly distributed, perfectly flat, perfectly boring. Right now, the universe is interesting because it is clumpy. We have hot stars and cold space. We have dense planets and empty voids. Energy flows from the hot things to the cold things, and this flow of energy is what powers life, machines, and thought. You exist because you are riding the waterfall of energy as it cascades down from the sun to the earth. But the waterfall will run dry. Let us fast forward. Let us accelerate the clock of the cosmos. Billions of years from now, our own sun will swell into a red giant. It will swallow Mercury and Venus. It will boil the oceans of Earth and melt the mountains. Then it will puff off its outer layers and collapse into a white dwarf, a glowing ember the size of the Earth. It will shine for trillions of years, slowly cooling until it becomes a black dwarf, a cold, dark stone floating in the abyss. This will happen to every star in the sky. The massive stars will explode as supernovae and become neutron stars or black holes. The smaller stars will fade quietly. In about 100 trillion years, the last star will be born. It will fuse its hydrogen, shine for a brief cosmic moment, and die. The era of starlight will end. If you were to look up at the sky in that distant future, you would see nothing. No twinkle, no Milky Way, just an endless, suffocating blackness. The galaxies themselves will have dissolved. The stars that were once bound together by gravity will have been ejected into the intergalactic void or swallowed by the supermassive black holes at the centers. We enter the degenerate era. The universe is now a graveyard of stellar corpses, white dwarfs, neutron stars, brown dwarfs, and black holes. Life as we know it is impossible, but perhaps around the dying heat of a white dwarf, some form of intelligence still clings to existence, huddling for warmth, processing slow thoughts in the deepening cold. But even the corpses will not last. Physicists predict that protons, The very building blocks of atomic nuclei are not stable. Over a time scale of 10 to the power of 34 years, protons will decay. This is a horror hard to comprehend. It means that matter itself is mortal. The white dwarfs, the neutron stars, the planets, the dust, they will all dissolve. The atoms that make up the memory of our civilization will break down into lighter particles, positrons and neutrinos, and fade away. If you were a traveler in this era, you would see the solid objects of the universe simply evaporating into thin air. The ground beneath your feet would turn to mist. The degenerate era ends. Now, only the monsters remain. We enter the black hole era. For eons that defy human mathematics, the universe will be dominated by black holes. They will sweep up the remaining debris. They will float in the dark, silent kings of a dead kingdom. But remember Chapter 7. Black holes are not eternal. They leak, hawking radiation. Slowly, agonizingly slowly, the black holes will evaporate. They will bleed their mass out into the void in the form of cold photons. A black hole the mass of our sun takes 10 to the power of 67 years to vanish. The supermassive giants take 10 to the power of 100 years. A Google years. To understand this number, imagine an hourglass, but instead of sand, it contains 1 grain for every atom in the universe. Imagine that 1 grain falls every billion years. The entire hourglass would empty before even a fraction of the black hole era has passed. But eventually the last black hole will explode in a final, tiny flash of light. The last structure in the cosmos will be gone. We arrive at the dark era. The universe is now a soup of photons, neutrinos, and electrons, spreading out into an ever-expanding void. The temperature approaches absolute zero. There is no energy flow. There are no hot spots or cold spots. Everything is the same everywhere. Entropy has won. The universe has reached maximum disorder. And because nothing changes, time ceases to have meaning. Time is a measure of change. If nothing happens, if the clock hands never move, time stops. The universe becomes a timeless, frozen tomb of infinite size. This is the heat death. It is the seemingly inevitable fate written in the equations of thermodynamics. It is the ultimate silence. It makes everything we do feel futile, doesn't it? Why build a statue if the stone will decay? Why write a book if the atoms will vanish? Why love if the memory will be erased by the expansion of space? But wait, the sleepy scientist has one last secret for you, one last paradox to keep you warm in the face of the ultimate cold. Remember quantum mechanics. Remember that zero is never really zero. Remember that the vacuum is seething with potential. Even in the dark era, in the heat death, the laws of quantum mechanics still apply. The vacuum energy is still there. Fluctuations can still happen. There is a concept called the Boltzmann brane, named after the physicist Ludwig Boltzmann. He argued that if you have an infinite amount of time, eventually, random particles will bump into each other and form a structure. Most of the time, they will form nothing. Occasionally, they might form a single hydrogen atom. Even more rarely, a molecule. But if you wait long enough, and in the dark era, you have infinite time, eventually, a random fluctuation will assemble a fully formed, functioning human brain. This brain would be complete with memories, a personality, and a feeling of existence. It would appear in the void, think, I am, and then dissolve back into the chaos. In fact, statistically speaking, it is more likely for a single brain to fluctuate out of the vacuum than for an entire universe like ours to form from a Big Bang. Some physicists argue that you might be a Boltzmann brane right now. The room you see, the text you are reading, the memory of your childhood, it might all be a momentary hallucination, of a brain that just materialized in the deep future a second before it freezes. But let us think bigger than brains. If a brain can fluctuate into existence, can a universe? There is a theory called Poincaré recurrence. It suggests that if a system has a finite number of possible states, and you wait long enough, the particles will eventually return to their original arrangement. If you shuffle a deck of cards enough times, eventually you will shuffle them back into the exact order they came in the box. The universe is a deck of cards. The atoms are the cards. The laws of physics are the shuffler. Given infinite time, the quantum fluctuations in the dead, empty universe might eventually trigger a new Big Bang, a spark in the ashes, a new fire. This leads to the idea of the cyclic universe. Perhaps the heat death is not the end. Perhaps it is the winter that precedes the spring. Perhaps our Big Bang was just the result of the previous universe's heat death finally rolling the dice correctly. If this is true, then nothing is ever lost. The universe is an infinite loop of breathing in and breathing out. The fire burns down, the ashes rest, and then, miraculously, the fire catches again. But what does this mean for you, for the consciousness we discussed in Chapter 9? It means that you are part of a rare, precious, and fleeting moment of complexity. You are living in the Goldilocks zone of time. You are not in the chaotic inferno of the early universe, and you are not in the cold gray soup of the degenerate future. You are here now, when the stars are shining, when the atoms are stable, when the chemistry of life is possible. The terror of the end gives value to the now. If the party went on forever, it would lose its meaning. It is the fact that the party must end that makes the music sound so sweet. We have traveled a long way together. We started by looking at the empty space in your hand. We watched particles behave like ghosts. We saw the universe split into many worlds. We stared into the abyss of black holes. We questioned if we are living in a simulation. And now, we stand at the end of time. The science tells us that we are small. It tells us we are temporary. It tells us we are made of dust and energy, destined to return to the void. But the science also tells us that we are the way the universe knows itself. For billions of years, the universe was blind. Then it evolved eyes. It evolved you. You are the universe looking at itself in the mirror. You are the mechanism by which the cosmos feels awe. Without you, the stars are just nuclear explosions. With you, they are beauty. Without you, the black hole is just a gravity well. With you, it is a mystery. You are the meaning. So, when you close your eyes tonight, do not fear the dark. The dark is the natural state of things. It is the canvas upon which the brief, brilliant masterpiece of your life is painted. The silence is not empty. It is the sound of the universe holding its space for you. We are travelers on a ship of light, sailing through an ocean of night. The shore is far behind us, and the destination is unknown. But we are together. We are entangled. We are written in the same code. Keep asking questions. Keep looking at the stars. Keep wondering about the space between the atoms, because as long as you are wondering, the universe is alive. The journey does not end here. The journey is a circle. And perhaps in some distant fluctuation of the eternal vacuum, we will meet again. Sleep well, stardust. The universe loves you, because you are the only part of it that can love back.